are hopefully going to get the model rendering. I am pretty confident we can do that. So yeah, let's see what we can do. I've been kind of thinking about some City Rust problems that I shouldn't be thinking about because they don't have a lot to do with what I want to do today. But I just kind of got lost in thought. But anyway, yeah, I think I can make this work. So let's see. Hello, Volvo, hello, Bokte, hello, Nios, hello, Tim Kasky, hello, Nick-chan. Let's see, what we can do today. I got some water. So, yeah, I have been thinking about how to, actually implement the model. Actually, I was wondering about what to call this because, so we have the model loaded, the model data in memory. That's called a model. We want to render the model, but there's a thing in between, which is basically how you deform the model into, like how you go from the model, which is like all the data from the model in RAM, to like a pose, right? A model that is already in a given pose. And I was wondering what to call that part of the framework. And the best thing I could come up with is driver. Which I think kind of makes sense. So you drive the model, right, from parameters, and you get a bunch of meshes out. So yeah, I think we're gonna go with that. So we're gonna be creating a new component, a new module today, and using that. I've also been thinking about how to organize the crates, and I think we are going to move the file stuff and this into a core Ayagami crate, which is gonna be sort of the core of the of how models are represented, and it includes the file loader and the driver. And eventually we'll probably also include the physics engine. And then we will have the renderer be a separate thing, or possibly actually the same crate, but a different a feature flag, I'm not sure. Shaders make pixel shapers to deform the model shaper. Maybe, but it's not exactly, because it's not just deforming, it's also changing like colors and things like that, so it's a little bit tricky. Anyway, and also shaper is a term used in font rendering, so I'm a little bit worried about that. Anyway, that's the idea. So yeah, I've been thinking about some City Rust stuff that I shouldn't. Stop myself. Stop thinking about that. Stop thinking about that. So I think we're pretty much ready to just jump right into it. Anything you'll be dogfooding Ayagami? I'm not sure, but I think it might be sooner than you think, because I might know. Let's just say that I know some people who are interested in this. I'm not in this alone. I'm doing all the reverse engineering stuff. I want this to be like, proper and black box and like safe and like 100% legit, to make sure we don't get into any legal trouble. But I have people who are interested in using this code in applications. So yeah, we might be using this pretty soon. I can start putting the file parse into a different crate. I mean, I could, but the thing is, like, it's the file parsing code doesn't really have any hard dependencies other than on like fairly simple and well-known Rust crates, and stuff you would want to use anyway, if you're doing any kind of file stuff. It could just be a feature so that you can turn it off if you just want to use an editor. But ultimately, people are either going to be using files or using this as part of an editor. So opens up someone to modify the models without everything else. Yeah, but the thing is, well, first of all, the file parsing isn't really intended for editable models. So the thing here is that, okay, this is a little tricky. How do I put this? The idea that I have in mind is the file parsing I have now is basically just a it's loading the model into memory, but it is not a framework for editing the model in memory. The assumption is actually that the structures are immutable, and I don't expose any methods that would make those structures mutable. So it's really a read-only parser. I think if you're editing models, you want to load them into a different representation in memory, and that's going to be a whole different thing. And then you could have that representation be implemented the model trait, so you could then render it using the same rendering code. But I'm not currently this part of the code that I'm working on is not really intended to be used to edit models yet. It's really just a loader. For a model saver, for example, you would basically want to load this into a different representation and then do a whole sort of route out pass where you sort things in the right order and all that. So, and the thing is, the model loading is the thing with all the dependencies. The model driver part is pretty much going to be vanilla Rust with optional SIMD optimization. And that could just be a feature. So, I don't think there's a reason not to have that, even if you don't use it in the same crate. Now and same with the physics engine. The physics engine is going to come later, but that's also it's so simple that it doesn't really matter if it's there if you don't use it. The renderer, though, that depends on WGPU, and that's probably worth having in a different crate. Okay. So yeah, that's the idea. I've been wondering about how to optimize the indexing stuff, because there's the thing where let me tell you about it and then hopefully not spend too much time on this. So one thing that we have is that we have these collections, right? So the model is generic because I do want this to be usable in an editor eventually. And so we have this collection stuff. I'm going to replace something though. I'm going to change this UID into, I think, just a model parameter. So all the collections use the same UID type to make it a little easier. And the thing is, so for a read-only model, these UIDs are actually indices into linear arrays. And when you have an implementation that is using only read-only models, you would want to keep all the data for the items into just like a vec. However, for an editor, it would not be a linear array. It would be some identifier that probably increments but could have holes. So for that, you would want to use a hash map to map them. And I've been wondering about how to implement, some kind of setup so that a renderer or the driver actually can use a hash map by default, but then use a vec as an optimization for a special case. And the thing is, I keep coming back to I need trait specialization, which is not a thing in Rust that is stable. So I don't really know what to do about that. We could just have the shaper be, take a type argument where you can tell it what to use, and assumes it's what is correct for the implementation. But it would be very nice if you could just have that be sort of generic without having to build it into the model type as a fixed type. You could have type something equals, some kind of collection of arbitrary items that maps, but then you would be locking people into using, say, hash map, right? And yeah, I don't know. So I guess we're just gonna use hash map for now and worry about this later. One thing though is that I do have this index buffer and text chord buffer thing. I might want to split these into a separate trait, because these are only exist for static models where there is a single index buffer, a single text chord buffer for the whole model. So I might want to split these into model and packed model or something like that. But for now, let's just keep it a little bit simple. Keep it like this. And yeah, I think I can just jump into it, and I need to stop worrying about this because I'm otherwise I will spend forever on figuring this out. But I do want to move the UID to the model because I think I'm trying too hard by putting the UID here. How did I do? I actually forgot. Did I end up using... I used... Yeah, I just used E32. So I think I'm just going to move this as to the model because it's not really worth having... potentially different IDs for different items. That doesn't really make any sense. For the internal file format stuff, I actually use wrapper types for the UIDs because it makes it a little easier to not like accidentally confuse pointer types and things like that. But I think for the external interface, I'm just going to use a U32 because at this, like, there's no pointers kind of involved here. It's more like it will dereference the pointee for you, and then if you want the UID and then to reindex that, you can do that. So I think for that reason, it doesn't make a lot of sense to like yeah, it doesn't make a lot of sense to really have that be a separate thing. So let's see, where am I? Ambiguous associated type self model. Actually, this can just be parse model UID. Even U32, I don't think it even needs to be a type like that. So item UID here does need to be self model UID. I think that can just be U32 there. And to the core item, I should just use a word type here. Hi, Teresa.
Do you need anything?
No, I'm good. Does this work? I think this kind of works. What's a trait? Can I use? I'm not trying to set it. I'm just trying to. Can I constrain this on? I actually don't know if this works. Oh no. Okay, that's another thing that's not working. Okay, so this one doesn't have to be here. But this one should work. And this also okay, so it doesn't need to be okay, it doesn't need to be here, sorry. What am I doing? I thought you could put it in a where clause, but I guess you can't. And then I guess these should be model. Yeah, these do have the model self-constraint, so that does work. Okay. I think I didn't break the build too much here. Let's see. And then, yeah, the renderer complains about the UID, which is actually just struct state, art mesh, and this T model, so it's actually model UID. Just way easier. And then we don't need this. Yeah, this fixes this issue, which I had here, which was really annoying. So it's way easier. Yeah, that's very nice, because it fixes this dumb... this dumb lifetime issue I had here. Yeah, this is much nicer. Where am I? In the RS. Okay, so that fixes that. And now we can start with the new crate. So I think we're just gonna go these into Ayagami. It should just be the main things. We have source file, we have core, lib, main. Yeah, so this runs, and this as well, the textures. Not in the right place. So now let's create a new module. I think this is gonna go in here then. So we have file, and then we have driver. So let's go back to Ayagami file. Actually, actually not Cargo, just driver. And yeah, we're gonna have a bunch of things here. So we probably want to have something like what kind of files we want here. We need something for something for deformers. You probably need something for anyway, let's just start with this and start writing code and see how it works. So we're gonna move this state thing from the renderer because you don't actually want that in the renderer. So this goes away. We're gonna put that here. Not in the former, sorry. This goes in where am I? That. And we need the more RS here. In the former, well, so this can just go in mod for now. Always ignore. So things that need a state in the that need a state, and we need these item state things. Yes. So yes, I want this kind of default straight thing, impl for hash map. IT, yeah, that's good. So do I want to call it art mesh state or do I want to call it, yeah, art mesh state is fine, I think. So struct driver, and that does need to have to be generic over the model type. T core model. We'll call this use create core. This is macOS. So driver. And yeah, this is just gonna be this is much easier than the stuff I was doing for the model because it's just a single struct. There's no multiple implementations involved here. So function, let's see, we need a new, and the model is going to be just like we did here. We're going to use use cd sync. Do we want a mutex? Actually, everything in the model is read-only, which means we don't actually need a mutex. I don't even know why I had a mutex there, because we're not mutating the model for anything. If your model is mutable, then you would need to... Yeah, the problem is that if you make the model mutable, which is desirable when you have an editable model, then you would need a mutex. Is there some way to work around that, actually? Is there some kind of type that you can use for, like a mutex that can be compiled out if you just use a... like, immutable type? I'm not sure. I think I'm getting into premature optimization again. It's not mutable right now, but like for example, let's say you have an editor and the editor is single-threaded and you're rendering and driving the model and editing the model, then if the driver has a reference to the model, then you wouldn't be able to modify it, even if you're not calling into the driver. And so that's why I had the mutex in. But ideally, what I would have is, you know, a setup where you can have a different type that is, you know, basically just a like a derived model or something like that. And you give it that. And I don't know if it's an easy way of doing that. I don't know if there's some kind of Rust trait for that, you know, where you can put in a different container type. Because you still, if it's a mutex, you have to lock it, right? So there's some kind of like mutex where you can have like a trait that is like replaceable with a no-op if you have a read-only implementation. I'm not sure. What's the cost of reloading the driver itself? So I think it's because the driver contains state. Like if well, I guess it doesn't really. This driver is not going to contain state, but a driver it only contains state for optimization. But when you add physics, it would start to come into play. Yeah, because it's not that high, but you wouldn't want to do this for like, you know, every pixel you move a vertex. I think that's a little bit not great. Because the thing is, it doesn't invalidate the state, all the state necessarily. If you, for example, modify a vertex in a mesh, then there is no state associated with that. If you only have to invalidate the state when you add or remove items. Actually, really only when you, not even that. You only have to invalidate the state when you change potentially the tree, the hierarchy in the model, because some of the state might be dependent on that. So, there's basically going to be... The initial implementation is going to be fully stateless, essentially. Like, the state is only used internally. But... So you can be clear at every frame. But then eventually there's going to be, like, a dirty flag, right? Where, if a parameter changes, that only updates the state for the elements that need to have the state updated. So, essentially, you would have, like, an invalidation for the state. But you don't have to invalidate all the state necessarily, only the portions of the model that changed. Well, let's just keep it. I guess let's just use the ARC version for now. I wonder if there's a trait. Because there's also the issue with the async, right? Where you would want to be able to support async. No, that's not what I want. Nah, whatever. Let's just do it. Let's just do something simple for now, and maybe we can maybe we can just wrap it into like a model ref or something like that. This could be a trait essentially, I guess. Or we can just wrap it later. Okay, let's just make it simple for now. Actually, I think there's a Rust borrow trait or something like that we can possibly use. Yeah, hold on. Borrow returns an and borrowed. Or is there like a guard trait we can use? No. Borrow trait. Maybe there's something we can use. I think, you know what? I think in the, for the driver, maybe one thing we can do actually is just have it a, yeah, actually, no, this makes more sense. How about we just make the driver not, like, just have it optionally, have the model instead of always have the model. And then you can just steal it from the driver when you need to use it somewhere else. So if you have a single-threaded app, then you can just take it when you're not using it, when you're going to mutate something. Otherwise, yeah, that might work. Either that or to just pass the model for every single function, which isn't that bad. Yeah, maybe it's easier to just do that. Just pass the model for every function. Yeah, actually, let's just do that. The only question is then, oh no, but if you do that for every function, it gets really annoying with like the art meshes and things like that. One thing we could do though is we could have a kind of output struct. Because we're gonna be okay, let's think about the API we want for this. Essentially for the model, once it's driven, you're gonna be returning a set of art meshes, and those will be they will have like mesh data, and yeah. So I think we might just be able to play a little bit with Rust lifetimes here. And that way, you can then use whatever lock type you want for the model. Yeah, that makes sense. So essentially, you would have a drive method that then returns a reference to a structure with a lifetime that includes the lifetime of the input model. So then that knows about the model. Yes, that makes sense. I think that makes a lot more sense. And I think you can yeah, you would do like something like a driven model, right? Output. And so this would have a lifetime for the model. And so then I can keep the reference. And we could even have this be a reference to a an internal thing in self. Does that make sense? No, because oh, it can take a self reference though. Yeah, it can take a self reference. So then this could reference a state. And then yeah, you can do like this. Yeah, I think this makes sense from a Rust point of view. And so then we can literally just have we can just have this return, like modify the state. And then we can put things in driven model, or we can just have it in self. Let's do it the other way around. This would be pub from drive, driven model. And so That way, the driver doesn't hold a reference to the model. However, when you drive the model, the output is tied to the model. Yes, that makes sense. There is no inheritance in Rust. Rust does not have objects. Driven model is not composition. These are references. So this is just a separate object that contains a reference to a driver and a model. But it does this Rust lifetime stuff that basically means there are no smart pointers or anything like that here. All of the tracking of lifetimes happens at compile time. Yeah, that makes sense. Yeah, it's essentially composition. But the important thing to realize is that the owner of the model and the driver is actually whoever's calling drive. You are returning a structure that back references the data that is already owned by the caller, and the compiler knows when you call this function that the caller is not allowed to do anything else with the driver or the model until it stops using the driven model. So it's really fun what you can do with Rust lifetimes. Sorry, I have a throat mint because my throat is not great today. Okay, yeah, I think this pattern makes sense, and that way we remove the whole, having to possibly have a mutex and whatever story there. Okay. I like this. This makes sense. I wonder how the physics is layered on top. The physics is actually entirely separate. The physics takes parameters as input and outputs parameters. It is a completely separate module. So the physics will be layered on top of this. Okay. So now let's figure out how we want to drive this. So we say new. Do we need a model for new? Not really, actually. Because oops. I don't even know if we're gonna have. We might just have state be the whole driver, because honestly, I'm not sure if. I mean, everything is going to be the state if we make it stateless, right? Like, if we make the idea stateless where you can just clear the state out for flushing things, maybe this is actually the driver itself, quite frankly. And essentially, we want to have ArtMesh state. We are going to have deformer state. Deformer. Actually, there will be rotation and warp deformers, but deformers are referenced by a parent deformer ID that includes both, so that'll have to be like a enum. One slightly weird thing is that, okay, I'm trying to use a higher level representation of the model that doesn't depend on the intricacies of the Live2D file format. So there's one thing here where in the classes, for blend forms, we have a bunch of maps, and that referenced warp deformers, which are actually a subset of deformers. I don't necessarily want to expose this as a separate collection in the model data model, because I mean this maps very nicely to an enum in Rust, and I think I want to keep it that way. So and honestly, the way these blend form params are mapped, I think I want to actually just essentially load these in as like a hash map or something like that, and or just yeah, I think I probably want to, like, in the model load code, just kind of remunch some of these structures into something a little more reasonable. Because this is clearly meant for, like, you know, a very specific implementation that does things in a specific way. And, like, I could do it that way, but I'm trying to make it a more generic, like, user-friendly API for this file format. So I actually want to, like, sort of lift some of these constructs into a higher level representation that is a little more well-behaved. Because, like, doing that at load time is going to be very cheap anyway. And, yeah, I think that makes more sense. Model object driven model object physics maybe no. So the physics will actually just basically contour the driver. So the way you would do the physics is that you would set parameters on both the drivers and the physics the physics would give you like the physics just takes a dictionary input of parameters and outputs a dictionary of parameters, and then you could just plug that into the driver. Like there could be an apply parameters that takes like a hash map as input, and then you would just feed the physics output into that. It's really a completely separate thing. Like you could use physics from one model on another model, and I mean, it would probably not do what you want, but the only references are to parameters. So it really doesn't need to be very well integrated. It's very simple to plug together by hand. So yeah, I think the main issue is going to be these references to deformers that I have here. We have, if you look at the beginning, we have this deformer that points to different types of deformers. And then the Artemis has a deformer reference, which is what we want. And then, yeah, only these blend forms reference the subtypes. But these blend forms, anyway, honestly, I just want to have these blend forms changed into arrays on the parents. So I think I'm just going to add like extra objects at the data model layer. Actually, I think we should do that now because we're gonna need those to make sense of some of these parameters, and it's a good thing to get going first. So how about we do that first? There's one thing we need because yeah, we're gonna need. There's also another thing. There's an annoying issue with this multiply and color and screen color stuff they added to ArtMesh forms. And before version 5, they added it. They had an implicit reference here. I think I'm gonna have a post-processing pass where I copy that into the new color items. I basically want a post-processing path that upgrades all models to version 5, so that users don't have to worry about anything. And so I think, yeah. Let's write some code for that in the file. I think we can do like an upgrade to v5 or something like that. And that'll just have to be open code. I don't want to put it into the macros thing because it's not that important. Load. Yeah, we can just have like an upgrade function here. And this could be private, and we just call it from load. So we would keep the version number at the old one, but we would basically just fill in things that are missing. So for that, we need to know what the versions are. So you can see what added, like bilinear interpolation, and then these color forms. I keep it the version of the old one because the caller should know what the capabilities of the file are and like what it originally was. And you can, in theory, just write out the file as the old file, and it will be the old file. So the new files are basically what this upgrade thing is doing is filling in default values for the missing things. But it doesn't mean you're actually using those features. So I think the caller should know if the file was created with a certain version, but also the caller should be able to access the data from the newest version and expect it to be what it is. So what we would say is let mat ver equals self version. I think I do have that. No, I don't. Where do I have version? Did I not put it anywhere? I think I didn't put that anywhere. I probably should put that somewhere. In parse the model here in classes, that's at the end. Yeah, the canvas. Create. Oh, there's no default for version. Okay. Yeah, that's just because of the part stuff I did. Let's just have a default for version. Just do that. The output might not be identical, but outside validations, would you care? What do you mean? Just it's more like if you're a user of the model, you can skip certain things if you have an old version, for example, possibly. So I mean, I think it's just useful metadata. You know, what version was the model created for? Like, you might want to show that to the user, right? Like, what version is this compatible with the file? You don't have to process things for a version, for older version files, right? Like things that are not supported yet. Anyway, let's just see if ver is. So let's just open code some stuff here because I'm trying too hard with macros. Like I could declare defaults with macros and stuff, but I think I'm just trying way too hard. This should just be open coded. If ver is less than, so we have the version 3.0 is basically the base, so it really should be supported. Just put an assert in here. v3.0. Oh, and those are the types. I think in mod here, I need a. Actually, no, you know what? This is just silly. I can just have a, yeah, because I don't like having types like this that have an unknown in them. I think, I just use an option. That's how you fix the default problem without that. So it's just version some ver and then just do unwrap, and it's a hack, but it works. Always having that being part of the APIs, and don't need this assert. So okay, what happened in the versions? In version 3.0, that we assume everything is at least 3.0. I just kind of split this just in case. Then we have version 3.3 added some stuff. So this can just be empty. So if ver is less than 3.3, actually, if self version is less than 3.3, don't need the mod here. Then we just create the bilinear interpolation stuff. So you would just say self dot warp deformer dot bilinear interpolation equals vec Actually, there's no new. I want to create like a like a vec with default even thing. So, let's just create a little internal function here that returns. And then we just do the resize width. Actually, this should be so we have copy and clone, just so you put the resize val. And it needs t clone, so and so then we can just say or deformer count comma, and it's just bool 32, which is false. So do I have that? I should have those types in there somewhere. Can you have associated types like that? I don't know. Const. Actually, just make these like this. If you can do that, actually, can you do that with structs like that? Associated items on structs? Probably not with these, right? Let's just do it like that. So that fixes version 3.3 in classes. I think that's the only thing in version 3.3. Yeah, that's the only thing. So then we have version 4.0. And that actually only added a field in the render config, which has already existed. So we don't need that. So then for 4.2, that added all these color forms, right? So if we don't have the multiband screen color, we actually need to add colors first. And the problem with this is that actually we need to add them for every form, which is kind of painful. So if we don't mind the overlap, I think everything has a forms argument. So this is probably should be a little macro, because this is on art mesh, on warp deformer, which has forms, on rod deformer, which has forms. Yeah, on those three things. Do I want to use a macro for that? Maybe not. Let's see. I think I can just use like an add colors thing. Yeah, let's just have like an add colors. And I do need a self for that. Actually, You can just put it here in self even. Add default colors. And this would be an index into color forms, which is actually a I32 because it's weirdly generic. Let's see, default colors. So for that, we would have to add multiply and screen colors. And then these are actually RGB arrays. So I basically want a extend. I need like an extend width, I guess. Hold on. Rust vec. I need to add copies of an argument. It's basically the same as like append adds one, extend from slice, from within extract. I want a essentially a resize width, but actually appends. Yeah, you can use an iterator for that. Or I could just resize with. Or maybe I can just add all the colors all at once, really. Nah, okay, let's just do them incrementally. Resize new count. And the value is 1.0. And then this is screen color. Yeah, that should work. And so then we do for A in art mesh count. Let's just open code it like this. Actually, no, because all of them are going to be included. So what I really need, oh no, I do need the, yeah, I need an append. So art mesh dot, and then we have the functions here. I thought I had these in the oh no, these are for the references. I guess it'd be a U32 so that we can use the count straight from that. Oh, and actually, this is for the forms, but we need more for the parameters, even. Wait, hold on. How does this work? Oh, I get it. So the reason why they... Right, Right. So this doesn't actually make any sense. Because we're not going to use this for anything. Okay, I get it. So, this doesn't actually make sense. We're not going to use these. We're not going to use these references at all. What we actually want to do is for all the art meshes, we're going to ignore these. We're going to ignore these. Oh, okay, no, okay, I know what I'm going to do. If we have, this doesn't make any sense. Because those colors were later moved into the forms. And that's why they moved them into the forms, because before they had a number of colors that were all sequential for the forms in a like for a given art mesh. And then they added the blend parameters, and because they added the blend parameters, those were not consecutive anymore, contiguous. So they had to add separate references for the colors into the forms. So actually, we're gonna upgrade straight to 5.0 and ignore this whole thing. Which means actually what we want to do is yeah, so if it's less than 5.0, which is when we added these colors into the forms. Yeah, and the maps are fine because these are new. So we go through the forms, not the art meshes, art mesh forms. That makes sense. And then we can actually just have them all reference the same color. Because these are just references. So we don't even have to copy and paste this forever. We can just say that all the multiply colors and all the screen colors are just 0. If it's less than... yeah, if it's less than 5.0, then we can basically just cheat. We can just say... those were added... eye color forms were added in 4.2, right? So if it's less than 4.2, Actually, do I even want to do this? I might just want to have a in the higher level view where we don't even have colors. Or I could just return none when there's no color. Yeah, we don't even need this. If ver is let me go. Then this is going to be like the color upgrade code. And so this only has to fill in the forms, which means we do have to go through all the art meshes. And essentially what we do is we have this color forms, and we just have to replicate that into the forms. And why is that an I-32 actually? I guess it could be -1 if it's not. Why did I make that I-32? I guess it could be negative if there's no forms. I don't know actually. I think that's supposed to be a U-32. I think that's a mistake. Because I don't think I've ever seen that as -1. I probably want to use the accessors for this. This is the Yeah, I want to use the so for f and am dot form for each form. We want to get the it's not iColor forms. What is it? Should be. Hold on, this is not a thing. Alright, FI color forms because it's a field. And this is actually a U32 pointer. So form views, and we need to just say f dot. Right. We don't want the form views. Forms views, but these are not mutable, so we actually want to mutate them. So we want to do that as just it's more like the range forms. Okay, it needs to implement the fine. Okay, this doesn't work. Yeah, that'll work. It's just a little weird, but it'll work. Not worth implementing the iteration for ranges like that. Okay. Or we can do it later. So self.artMeshForm dot I multiply color. And so then this is essentially missing. So we need to add these to the forms. I guess we want to just resize these first to the proper size and then build them up. So let's do that. Yeah, I think we just end up with that. And then we just mutate it here. Yeah, that works. And then repeat for the other things. And so this fixes the issue where there's this fixes the issue where this color forms thing is a pointer into multiple arrays. I think what happened is that they probably had the colors as originally a single array of like multiply and screen colors as a single object, and so it makes sense as a pointer to that. But because it is, you know, connected to the forms, you can't get these as part of the form, and then they moved them. So yeah, we are just going to do this upgrade here. And we also need the screen color here, actually. Because they are the same. Yeah, I think that works. Kind of ugly, but... And so then we just need to initialize these. These need to be in warp form. Yeah, a little ugly, but it will work. Okay, so what else do we need? That might be everything, actually. So we have 3-3. 4-2 just added color forms. It added those. It added extra things to params, but we can just have defaults in the like getters for that. Blend shapes, yeah, those can just be all zeros. I guess we just initialize some fields for these. Yeah, I can just add these parameter ones, I guess, or 4-2. So Ang02 is not supported. Key points is a pointer to a key point. Oh, we don't have those. So that's gonna be empty because that would have to be like an option since we don't have it. So we'll deal with that at the access layer. But for blend shape, we probably want to just have these as false. And blend pair maps as a flat vec of actually blend pair maps Yeah, just something like that. What else is in 4.2? I guess we could just add the colors here too. If it's less than 4.2, we could just add them in on the forms. And so hold on, this is param count. What am I doing? Warp. Yeah, here we go. Art mesh, multiply screen color. This is art, sorry. Art mesh form, and there's warp form and rot form. And what else do we have? Also, now key points is a it could just be a empty array, I guess. But I guess one thing, it could just use the first map, I guess, key point set, but that's not very useful. So yeah, we'll leave this one unset and have the data model handle it. This one is just unknown, so we don't care about it. And I think that's pretty much it, because everything else is new objects. Okay, yeah, so this should take care of the backwards compatibility in a way that doesn't make it too painful. And this fixes this annoying thing that we had. So, okay. Let's add some debug here. You can do these like that. Oh, I need to add the 0 colors here. Yeah, so we need to do the yeah, that should work. So we only use 2 colors, and then we all point at the same color for that. Okay. Can you call iter on range forms? No, it doesn't work because I need to implement iterator for that weird range type. What's going on here? No, it's fine. Okay. So that's the upgrade part, and now I need to, how was I doing before this? I wanted to do something. I completely forgot. I lost my track. Yeah, so this fixes those references, and then I need to do something about these objects, right? The maps and this kind of stuff. Because everything else is mostly, like, kind of follows the tree format I want. And then there are these like blend pair map and blend form map that have issues, right? So these are annoying because they essentially get added to the like I really would like to reference these from that work deformer, right? Instead of just iterating a list. Essentially, I'm going to create a bunch of back references. So I think I can just do that by having some extra arrays. And so for the extra arrays, essentially I just want to have like a like global thing here that creates successors but doesn't parse. And actually, you know what? I could just have that as a pass that never happens. Yeah, and that's the easiest way to do that. I just go in the in parse py here. Sorry, in what is this mod? And so I can have an internal pass. Sorry. And then that can just have fields that are never in the file. And so we can just put that in here. So for example, for rod deformer, we have forms, and we could just have a blend forms. Because blend form map, sorry. Blend, and just call them like blend maps, because that has the parent map and the form counts and the blend weight limits. Yeah, so then we can associate those. So let's do that. So if we go to classes here, let's just look up the blend form maps and just add some internal cases for that. And then we can just iterate them. And the only trick is that internal will... I guess we have to make sure that they are treated as primitive and not as any of my special cases here. So I think that's fine though, because we only use... Actually, no, they could just be, yeah, what am I talking about? They can just be references to the maps objects. Yeah, we can just reuse the same mechanism we already have. Part form, warp form, rod form, art mesh form. Yeah, we can just point back to these, really. And... or just go straight to maps, actually. Yeah, just go straight to maps. And since it's the option and, which I don't even know if that's implemented, I might need to add that. Yeah, we don't have optional lists. Oh, wait, but optional list is just an... it would just be an empty list for things that don't have any. Yeah, that works. But I don't want to use the count range thing. That doesn't actually work. I might actually just have Vex here. No. Yeah, since we already have a range in here, it'll just be a pointer to these, I guess. An optional pointer back. So then, essentially we would have internal. And so we have these for warp, art mesh, and then part rot and glue. So we have all of these. Mm. Oh, it needs a comma there. Interesting. Some weird macro stuff, yeah. Warp deformer, rod deformer, art mesh, and then we need part, which is the first one. And finally we need glue. And then we just want to load these in here, right? So basically what we would do is in parse, load refs. Is it find refs? And I guess this has to be an internal too. So and I probably should have... I don't know if I have conversion for those. I probably should have that in macros when I do the option stuff. I do have a from opt I for option I. I need the other way around. Like that. And then none actually works here. So there's no implicit conversion, but explicit conversion works. And then we can just say art mesh. And we would have rot, warp, and blend. Oh, sorry, glue. There, like that. Internal stuff. Okay. And then in find refs, we just iterate through all the items and find the original items. So the for art mesh, blend for maps count, blend for maps view, And do I have a ref thing in the view? I thought I did. The view should have a... that's a view ref. What I really want is a something that returns the index. I'm confused. What? Oh, okay, no, sorry, just had a save issue. And then art mesh can be indexed by, yeah, okay. It's actually art mesh 0. And it expects up, so into I guess. Oh yeah, and then we should have a conversion for none, or even just some. Yeah, there we go. And then we have a mutable issue. Does that work? Oh, the indexing? No. Yeah. Yeah, it just needs that. And then repeat for all the other types. Okay. Warp. 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 Deformer. Rot. 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 Deformer. Oh, and actually, do I want these to point to warp deformers and rot deformers? Or do I want them to point to parent deformers? I think I want them to point to parent deformers, and then this is a little bit trickier because of the extra indirection there. So hold on. In model, macros, model. Yeah, so this is the issue there. The classes, these point to the rod deformer, and I want to point to the parent. So I actually need another indirection there, which means I need a like a parent pointer on the deformers. Just call it deformer. And actually, I kind of want to swap these with oh, these are pointers, right? Probably want to have an assert here. Nah, I just want to say, yeah, that. These should technically be a parse error. If you have more than one, I guess, yeah, it's actually return a parse error from this one. Because the input file could have that problem there. So, let's see. For a parse error for that, we would want, let's call it duplicate reference. And then we have a if. Yeah, this is getting a little. Like I almost want to have a macro for this now. Let's make a little one-off macro because this is a little silly. There we go. That's what I want. Art mesh, rot, warp, heart, and glue. And the only problem is this one, which needs a separate item, rot, deformer, heart, and glue. Yeah, okay, so that'll be easier like that. Could have done it for these two, but whatever. Yeah, you can do inline macros like that. Okay, so this finds those references, which I'm gonna need later. For the blend form maps, but that's actually, then I need to get the parents out. But the parents are just for rot and warp deformers. So, that's just one array over the deformers. Okay, so we iterate over all the deformer views and I probably want to have an impo here for the deformers even. And that could go in classes, I guess. These need lifetimes, yes. Wait, what is an I-32? There should be a U-32 also. There's no way those are optional. There, okay. So now we have something to do the typed deformer view. And then we pretty much just say actually, I guess it could just be this one can be actual public function. Yeah, okay, so for warp we would say self.warp deformer dot I parent. Actually, what did I call it? Internal is yes, I deformer. So I need to resize those first. Actually, just put them here in the upgrade. I guess these should be option too. Just to make sure that they're all there. How did I do the... Okay, this is pubcreate.idx. Yeah, it should just be idx without a function. Yeah, equals there we go. And then just do the same thing for rotation. And this is calling the former. Wait, hold on, it's not V. This is T. Yeah, like that. Okay. So that gives us the refs. And so now in the higher level data model, we can just reference for each deformer what blend forms it has. And so that's gonna make my life a lot easier. Comma. And something else is here. Cannot borrow. Oh, okay. Immutable. Blend for maps is borrowed. Here at BFM. There, and that fixes that. Okay. Good. Okay, what's going on here with this? I cannot. Okay, another borrow issue here because this is borrowed by what? By the view. For 25, for 20. Why is that view also borrowing the typed deformer view? Because it does have the entire self thing. Okay, yeah, it's the IDX. And then it doesn't like into okay, that still doesn't like it because v.typed I think that works. Yes. I think there was some story about fixing these. In Rust, you don't have to do the steady stuff with the borrow checker, but yeah, okay. Alright, are we compiling cargo? Almost. It wants a... It does compile, it just wants a typed. And yeah, this is only a problem because this is mutable. For users of this class, everything works very nicely for the references because as long as it's immutable, you can have as many references as you want to self. So nothing really breaks. All right, cool. So we have find refs and where is this? This needs to be questions, I think. Eventually, I want to have a validation pass so this doesn't just panic on some of those unwraps and things like that. But okay, so now the data model, we're gonna need to expose these deformers now that we have the data in a format that makes some sense. So first core, let's see what we need for the deformers, right? So we need some traits for that. We have part, we have item, art mesh form. Okay, this is supposed to be at the top. Let's move this to the top. Let's go back to classes and kind of put things in order. So we have part. And then let's go in the same order. So we want to grab, these constants from here. Deformer type, blend node. This is a little tricky. How do we do this enum? If we were wrapping types with an enum like this, we would have to take the deformer types as generics. I guess it would just have to be like associated items or something like that. So we have item, we have part, pop trait, deformer, it's an item, and then the deformer, the subtypes do not necessarily have to be items because I guess you only really need the ID for the parent deformer. We don't need to expose the fact that the file has separate arrays of subdeformers. So pop trait warp deformer. And I guess we could just have the subtypes here. Do we want to do it like that? I guess we're gonna do it like that. Because enums can implement traits, but yeah, okay, hold on. And how do we do enums here? We have the deformer subtypes like that. We want that. Now we need the enum to be. Does that work? No, because then you need the you need to pass them as generics. I guess it could do like that then. Yeah, okay, so we just say warp, T warp, and rot, T rot. And so then this type deformer view is really just deformers of types whatever, right? But I don't necessarily want to import this in this. I don't want to create a cross dependency here too badly, so I'll just have these like this and then just kind of duplicate it here. Oh, you just gotta type the deformer even. Yeah, type deformer. Okay, so now let's have the functions here. We have the this is an item, and we have the ID, We have a pair map set, which is this kind of deal. We don't know that flag. Visible self. Then we have part. I guess this would be model. Target pair map. This is gonna be a little bit weird because of the traits. I really kind of want the lifetimes to all be. I don't know if that's gonna work. I guess let's try it. Self model, part. Yeah, I don't know if it's gonna work, but let's try it. Oh yeah, I do have this form thing, so it should work if I just do this, art mesh form. Which means this should be done the same thing here. I kind of want to use a macro for this mess here. Yeah, can I use a macro here? Just to write out this entire string. And then if I decide to do it a better way, it'll be nicer. Okay, where's my macro rules? Steal some of that from parse. Can you even put macros in types? I'm not sure actually. You might not be able to. Let's try. It does work, I think. Does it? Hold on, where am I? Oh, this is just copy paste. Yeah, it does work. Okay, good. So we can just have this deref mess here, and then when the target part form would be input deref target, self model small model. There, that makes sense. And that does not work. It's drf target equals. Right, or it equals. And then we're just missing the forms. Okay, good. Yeah, makes it a little bit easier. And then I could have an I for the iterator and just use this one. Yeah, something like that. And let's just add another one for type here for all of these. It's a little easier. Art mesh form. So then we need part form and all that. Okay, let's add a bunch of things that we know we're gonna need. At least try to get the core stuff. So we have part, we have deformer, the warp and rot are gonna be internal, but then we have art mesh, and we have param, and then we need part form. What form? Rot form. Art mesh form. Do we need those? No, actually, we can kind of just... I guess they should be declared here anyway. Art mesh form. Or those could be subtypes of the art mesh, actually. Because they don't need to be iterated from the main thing. So we can actually just take those away. And just have art mesh. As an associated type. But then the issue is we need this ref here thing, right? So we could do model type. You could do model type and just have it call it subtype. Let's see if that works. And so then we can just have self form. And it's a little bit easier. And you can just call this MP. Or PM actually. PM and ITM. And then P for just inside the type. Okay, let's see if that compiles before I go any further, because this might be very wrong. Part, form. And let's not do param right now. Okay, just make sure that I'm not completely breaking everything. So this does not work. Expected : I think it needs these. No? What did I break? Macro expansion is the complete expression. Expected : Oh, because it is PM. But that still doesn't work. Oh yeah, because I'm just missing the... Yeah, this is perform. PM is part. Where's part? Oh, okay, yeah. Okay, yeah, so P is broken. P needs self T. And I'm just dominating. I had an extra thing there. Okay, parameters, I'm after core model. I guess we need parent map in here. Okay, good. And then you just need art mesh form. It's not a member of trade core model. That is, where is that? Art mesh form. Okay, yeah, and then we just need to fix these in model. So if you go back to model, we don't use art mesh form in the model anymore. That goes in art mesh. Form equals art mesh form view. Oh, and now we have the issue with the... For yourself, okay, it just needs this, yeah. Yeah, it just needs this story there. What am I doing wrong with here? The form? And then, yeah, we need the parent map model here. So target equals, I think we just do that. Yeah, okay. And then missing part and deformer and that implementation. So let's add those. Parent map, art mesh. Okay, so we need art mesh, deformer, part view, art mesh, deformer, parent map. What do we have in core? Yeah, those are the ones we have. So this will get us somewhere. So let's start with part. Part for part view. And part form view needs to be an item, which we'll figure out later. Declare item part. Why do we have a lifetime that's not supposed to be there? I guess it's part view. And this function, I probably want to just have a macro for that. And I can just have like a special match here where this is parent maps gets mapped into that and just have all the special ones here in a single macro. And same with form. Form is going to basically do the same thing for every single potential yeah, for every single thing. Except I want to write this as self view, self form. And by value, do I have an into here? I need that. And that's a complicated one. Part form view. I think it's just because I need to implement part form view. Okay, yeah, and so then we need to fix the views in core here. For art mesh, I ended up with index U32 list. And yeah, let's use the same thing for this one, U32. Do we want to use U32? It's really just arbitrary. And I think it should be U size. Because we're indexing into like regular arrays of stuff that aren't really but we use U32 for everything though. Let's just use U32. Okay. I just kind of wonder because U size is the default index for like vectors and stuff like that. But I guess since this is an index into a key point array, it could just be U32. Anyway, okay, now what's going on with the form there? It needs to be an option because you could be passing an index that doesn't exist. Okay, that works. And they were missing form for art mesh view. Form. Art mesh view, the former. Wait, what's going on there? That's the former, which we don't have yet. Former view. Yeah, that's missing the trait bound for that. Okay, let's go continue. So we have part view. These can go later. Let's keep everything in the same order. So art mesh view, part form view, pyramid view. So going in the same order, we have part. Let's do the former. Okay. So this one needs the subtypes. Type warp equals warp to former view. Rut. And then we do the standard stuff. So we need paramaps. And we need visible by value. And we need the part, but we don't have those declared yet. Form part. Yeah, I guess we just need a... Paramaps is special because of the set weirdness. You can have like item ref. I think it's just that. Let's see. If we go to Deformer, we can just say item ref part view and let's see if that works. No, that doesn't work. Okay, what's going on here with part? Why is part optional for deformer? Don't deformers always have a part? No, there can be deformers without parts. And how did we have the view? If we go to macros, we had some kind of view thing here. Deformer. No. Yeah, it should be part view. That should exist. Did I forget something here? Oh, on deformer. In classes. Oh, because this is and, that's why. And that doesn't work because we didn't implement optional pointers yet for double and. Actually, we did. It's just that they're supposed to... Yeah, those only ever exist for non-primitive types, so it should just be like that. Whereas and... Macros. Yeah, so then we just need the getters for that. And so then that just returns an option. There. Okay, so now we have a view. And I broke everything. Okay, I blend form maps. Because those have to be double ands. Okay, much better. What am I doing? Nope. Okay, so now it's complaining about option D, ref, field, and market. So we're back to issue and model. So for the ref, we actually need to return a ref, not a, yeah, so we need to do essentially that into ref. Ah, that works, yes. Okay, cool. And now we're just missing more types. Yes, okay, good. Good. Okay, so now just add more types. So we have deformer view, and we need to implement the warp deformer view. And rot. And then for typed, we basically would just return and in this case, instead of a reference to a type deformer, it would be these are references. But it doesn't work for field arguments. So then, how do we want to do this? We can't use impo. I guess we can have another type here that is like a warp ref. Actually, no, it's this thing, basically. We have the item, you can set the... Yeah, okay, I think this kind of works. But that doesn't work with this kind of bound. Because if I make it input deref to a typed deformer, no, that would still kind of work as long as I make it return a like the enum for that. Does that make sense? I think it kind of makes sense. Or we just pass the arguments here, I guess, because there's only two anyway. So, and that also doesn't work, right? Yeah. No, that does work. And, oh, does that not work? That probably also doesn't work, right? Yeah, that also doesn't work. But I probably need a where. Wait, what am I doing? This is just this. I'm kind of dumb, aren't I? Yeah, because this, of course, I'm so silly. And then I can just use warp ref and I always get confused with the impulse stuff. Warp ref and rod ref. Okay, that works. And so then I can just say, core type deformer self. And the types that I declare is typed deformer view warp. You know, I can just remove this type thing. It's already doing the same thing, so I can just move it here. Let's just move this code here, actually. Yeah, that works, I think. Okay, and so now this is complaining about this needs to return a ref. So it's a get ref. There, that works. Okay, I need to fix that one. I'm gonna take a very quick break. I'll be right back. I'm back. Okay, we're kind of getting somewhere. So we have a lifetime issue with item ref. And then it complains about paramaps. Okay, that compiles. Let's see if it actually works. Though honestly, this should be the lifetime A there, the parent lifetime. But it doesn't like that. Does not necessarily outlive the lifetime parent map self. I think I might want to fix that. No, it has to be self, because if we are using yeah, the trait doesn't know anything about those lifetimes. So it would have to be based on self, yeah. So the user has to assume that this lifetime is smaller than self. Which is okay. So well, let's see if it works. So now let's add driver into lib here, pubmod driver, and compile that. Oh, sorry, it needs to be oh, what did I just do? Rename to source driver. That did not work. It did work. Okay, there we go. So now we have some extra things to do. So we don't do this mutex stuff anymore. And we can derive default now. We don't have the lifetime mess. So that solves that. Okay, then we need the former state. There, now we take them out. Okay, good. So now, let's see if we can get some stuff out. And actually do some... if we can actually iterate certain things. So first we need to, we need to essentially, maybe the functions should be in driven model. So first we need to, let's see, what's the order of operations here? We're going to ignore the part sorting stuff for now and just put items in whatever order. First we need to essentially iterate all the art meshes, check all the deformers, and update all the deformers that are not that don't have a state. They don't have a state associated with them. So we'll figure out the invalidation later, but for now, say like calc deformer or something like that. Yeah, you can do it like that. So we iterate over the art meshes. So for art mesh in self.model.artmeshes, if let some deformer equals art mesh deformer, then self.calc deformer. And we're gonna have an issue with the lifetimes here because this goes yeah, we're gonna have an issue with the lifetimes because I'm taking mod self, but model is supposed to be immutable. Maybe it doesn't make sense to do it like this, and I should just keep passing model everywhere. Yeah, that's not gonna work because of the mutability issue. Okay, let's move these here actually. I thought I could get away with that, but I can't. So for calc deformer, we would just say So we need model T and the deformer. Would be deformer. The T deformer. Do we even need model here? We might not. Okay, deformer, option deformer state, get, so you get a UID. What is that not? TS model UID expected and found. Why is it expecting and? Because get this is I have this item state that I'm actually using for the hash map. For hash map IT. Let's call it lookup. Okay, Artbridge doesn't have a deformer. I think we didn't add that yet. That is here. Classes, deformer view. Let's add some parameters we're missing. So we have part, we're missing part deformer, we have visible. So those are the same thing as these. And so here in macros, sorry, in model, we implement those. Item ref for deformer. Okay, it's like that. And we're missing part. And then we need clips, which is one of these arrays, like param maps, but a little different. There's child collection. Yeah, that's what I want. Did I use that yet? No, I didn't use it. Okay, let's try that. And in macros, sorry, in classes, it's called clips. Okay. And going back to deformer here, calc deformer, and delete that. Child collection is a field type, and we need a function. And so we would get, we have the field, so don't need paste there. I think it's really just that, actually. Yeah, it might really just be that, kind of. Art mesh view is not an iterator. But what I did for the views is actually in macros. It's item collection of it's this stuff is what we need. Okay, and it wants the collection to be like that. And it's a iterator of references. Is that right? I think so. No, wait, hold on. No, that doesn't make sense. I think we have in core where that is declared. Do we need to return a deref or yeah, we need to return a deref because the iterator would be returning references, and so I need to map this into refs. Actually, no, just item collection should be returning those things because yeah, that's just an issue in model where item collection should be returning wait, we are returning a reference. We are. From items, it's just the iterator that is wrong. Item iterator should be returning. It is returning view refs. So then just the declaration here is wrong. It's into iterator item equals Dref. No, that is correct. So what's going wrong now? Okay, let's replace that thing first. If we're in model. I think I just have something wrong with the iterators in here. The iterators are supposed to return... hold on. Or did I just mess it up? Art mesh clips is ITM. Yeah, it's supposed to be a dref. Bref as dref target art mesh view. Oh, wait. This is an art mesh ref. Okay, no. This one, right, never mind. I am city. This is just the wrong implementation. Child collection cannot be implemented like that for this one because there's a different thing. So the macro might be okay, but it can't be used for this one. It's similar to what we need for the parent maps. It's the same kind of deal. So where's clips? Here's clips. So what we do is clips views. And that's an art mesh ref. And then it's I art mesh. Can I align some types here and make it a little more readable? Yeah, I think I can. Okay, good. Even that works. Can I use just this? No, that does not work. Okay. So it wants me to say back, but that's it. Okay, good. I'm probably just did like this one too. Yeah, that works. Okay, good. So back to the driver. Okay, good. So now we have the art mesh stuff. Let's go back to the model. We need to declare the extra deformer stuff. So let's go back to core. We need this information for deformers. So we have art mesh. Before that, we have deformer, warp deformer. So we need the parent map set stuff again. And those are actually the same as the parents, so they should be the same. We don't need to return them then. But we need the forms. Which means we need a form subtype here. And for warp, we would have vertex counts. So this one's a little bit tricky because the warp form, I would like that to return to know the vertex count. So that's a little bit tricky. This is one of those cases where I would like a some extra info in the forms. I could just add it in the parent model. Essentially, I want to have kind of a special case in the view where it gives more info. Or it gets access to the parent or something like that. Maybe that's what I need. It's like a parent field. So the views can reference the parent. And that will make some things a lot easier. Yeah, I think I can just kind of make that generic here in the refs. I think I can do that, and then that'll make my life a lot easier. Parent in the view, you like an option use size. And so then when we construct the view, and just say parent none like that. And then, yeah, this is gonna be a little hacky, but I think we can just special case it for this one. So state parent none, and I can just add it with parent. What is it complaining about now? A lot of things. Okay. Okay, there we go. So we have form and subtype. Warp form and rot form, which we don't have yet. Warp form and rot form. And so then that means that in model here, I can give it access to the parent, and that'll make my life easier with the like being able to reference things. So form is a special. And actually, we need parent maps for form to work. We don't have to expose it though, which is good. I need rot form and warp form. Rot form view. So then in form here, we can have it reference the parent, and that's going to be useful. Let's say with parent. Especially the model not found in self. Because I don't have the model. So hold on. Model. Yeah, because these aren't items, the subtypes don't work. I just need to type parent, really. Yeah, we need a model type, even though this is not a an item. And then we just put these here in model. And so then these aren't actually items. Yeah, okay, that makes sense. Okay, good, that compiles. And so then we have the forms for warp and rot, and those do have the with parents. So now we can use that in the forms to figure out which the parents are. So we can have a little extra thing. Actually, I could have the with parent be a separate trait, and then we can like look up the parent and have a type built into it. So in that case, we can just go and either in classes, in types, and have a child view. And so then here in macros, and I want it to be a separate macro. So we need to paste in here. And let's call this obj view type parent equals actually just not a parent is fine. And so then we can declare parent. There, so now we can declare the parents. And I lost the implementations here. Where is that? And then for parents, we would get like that. And then we need the refs here. It's what is this? Yes, self IDX. Self parent as object. I expect that U32 found use as. I guess we might as well use U32 here. And probably for index 2. Now let's just use that because of the... Nah, it's just U32. I'm gonna have to change some things here, but it's gonna make things a little easier. Just these have to be indexed differently. Okay, so now the with parent thing here, and my with parent self, and I guess we can just use a reference for that to make it a little easier. Okay, that compiles. And getting somewhere. So now we can have the parents for the forms, which is important, so we can make sense of the rotation and warp deformer stuff. So now, all right, missing fields in the forms here. Back to the deformer. So let's go to classes, and we have warp deformer view. So warp deformer needs let's go to core and declare the missing type. So we have parent maps should actually go through the parent. Forms however we need, and the vertex count should actually just be implied by x divs and y divs. So it's only size. This is just type size. By linear interpolation, and then the color forms is not necessary, and then that's it. So actually, this deformer thing is not even necessary anymore because we can use the internal. We can use the parent stuff. So I should just get rid of that. But I might need it to reference them when I'm not, when I'm not indexing to the other ones, I might need them. So that's okay. Yeah, I need those to reference from the warp blend stuff. Yeah, I need it at least temporarily for that, so we can keep that for now. Warp deformer, bending interpolation. Okay, and then I guess we'll add the blend form maps later. All right, I'm gonna take a quick break. Be right back. Okay, I'm back. Thank you so much, Marcin. Thank you for the super chat. Okay, so warp deformer, we have the bilinear interpolation. Don't need the color forms. Don't need that stuff. Rod deformer needs angle offset, which we don't actually use, so let's assume that's 0. And that's it. So we don't need anything there. Just the forms. And then eventually we'll have the blend forms there. So then for the actual forms, yeah, so this is one thing we were missing. In art mesh form, remember last time, here in model, we couldn't we couldn't set the end vertex because we didn't have the parent. So now we have the parent. So for parents, I have to be and self. Same in macros here. And so then we can say that we can get the vertex count here. Does Rust have hold on, Rust range syntax. Does it have a syntax for like plus something? Because that would be very nice. There's no plus, I guess. Yeah, okay. But I think I can just index it twice, probably, right? I can just say this and then say dot dot parent dot vertex count. Does that work? Hopefully works. It doesn't because there's a sub thing. Okay, never mind. Oh? Yeah, and then we need a E32 here. So this is start vertex. SE size. Or you can just do that. There, okay, so now we have the vertices actually cut up properly. And we can use the same story for the warp form views. You're gonna need this also. Not rot, sorry. Just warp. Okay, so now the rest of the model. We are in macros, now in classes. So the warp form has an opacity and a start vertex. And then the multiply screen color. Do you want an option here, or do we want to just always have it? I guess we can just always have it. So for color, we can just have a type. Does Rust have a standard color type somewhere? Is there any kind of standard color class? Possibly not. I don't want to have a whole crate for that. I guess not. Maybe just declare it like this, honestly. It's gonna be... At least there's a chance that this is used by other people like that. Okay, so for rod form, and here it gets interesting. We have opacity. And we have angle. And we have position. Let's say vertex, chord even, yeah, it's called chord. I don't think we even use the vertex anywhere. And then we need the flips. And flip Y. And the colors. And art mesh form should also have the colors, and it needs opacity, depth, vertices, and the colors. And in terms of order, they actually go on like that. And art mesh should come first. Art is after that, and then pair map, I think, is after everything. Yeah. Okay, so now let's implement all these things in the model. So first, warp deformer. Let's actually just click the button there. Okay, so this would just be by value. And then we need size. Order. And that's just returning that. Why is it not formatting? Probably because I have a syntax error somewhere else. Okay. So now in Art Mesh Form View, what else we need? A bunch of stuff. So these are by value, the colors. Oh no, these aren't by value. These are fun because they're references. So multiply color is could just make a macro for this, but essentially it would be multiply color view dot fr, and then yeah, it would just be like this. I think I need to give it a little impl here. Wait, where am I? Core color. So then I can just say self.color. Actually, self.multiply color view.color. Makes it nice and easy. Can I even do... I can do it by value and then like... Nah, okay, let's just do it like this. Screen color. So So you can have these in the warp form and the rod form. So opacity and depth are just by value. And then we just need opacity in the warp form. And rod form needs a bunch of stuff. So let's put these at the ends. And most of these are just going to be by value. So opacity, by value, angle, position is going to be special. And then scale for basic Y. Angle, scale, flip X, flip Y, and position is the only special one. So position is basically going to be the same thing as the one I did for deformer here. And I guess for size, I would just say chord also. No, let's use 32. Yeah, that's different because those are integers. Okay. I think that's it for getting deformers in, ignoring the blend shapes. And then we just need, yeah, ignoring the, okay, which one's broken here? Duplicate definitions of opacity, opacity, opacity. Where am I? I just have to there. So we need the driver. I guess the driver goes in loaded model. And in this case, the model can just be T, I guess. No need to do the Archimedex thing. For a simple render that doesn't require changes to the model, we can just say T. Okay, good. So the driver is public. And so that needs to be declared here as driver T. So no need for that one. And then in load model, we can just say, I guess it could be an arc T instead of arc mutex T if for the render. Actually, no, let's just keep the arc mutex thing in there in case you want to mutate it. Just here. Yeah, okay, there we go. And then driver, self model, unwrap model clone. Okay, that works. So we're back to the texture stuff. Did I break anything? I don't know. Let's see. Oh, okay, I did break something. We panicked on range index 148 slice. Okay. Oh, the vertex count is there's a divide by 2 deal we had to do, I think. Yeah, our vertex count is ×2. So the vertices. Yeah, okay. We should fix the type of the vertices. Return. I wanted to do that last time. Which means essentially that we need to reshape those vex. It's basically just this primitive thing. Declare primitive. Vertex chord F32 is that's the file primitive. But I essentially want to reshape that as a different type. And I think I can probably just declare a different type here for the primitives. Yeah, let's do similar to the conversion thing we did here. So if we do this kind of thing, and the same for text chord. And then I need to change the macro here. Declare primitive. So all I can do is like a I can do a TT and then make this repeat. Have like a type spec, and so I can just have a actually no, I can just do it. I think I can use the question mark thing here. I can probably just do type TY, and then have like the dollar question mark. Like mem type. Yeah, so that compiles. And then I would declare this as mem type. Maybe I should just make it not optional, make it a little easier. How many primitives do we have? Not that many. Vertex chord, key point, text chord, text index. Yeah, it's just a few. Let's just do all of them the same. Key point. Actually, no, you know what I can just do? I can just do it like this. City. Yeah, just like that. And so then that'll automatically expand. And so then this would be called file type and mem type, which is how do I call these? Yeah, file type and mem type. And then I just need to declare the read array for that, and it should work. I think I can make it work like that. So primitive reader reads into that. Where are those declared? And macros. Let's run type 2y. Actually, smart transparent reader is what I want. Yeah, smart transparent reader. Yeah, that works. And so then make sure this is getting parsed properly for the primitives. we're calling parse prim on self value, stringify, count data, and the problem is the count is different. And then the tricky part is all the references are going to be different. So I think what I want to do for that is some kind of like index, like stride declaration. Yeah, I think we can do something like that. Use size and item, yes. Okay, so you have the stride, and that's the only thing that's used for mem values, and we basically just want to reduce the count. So you can have parse error somewhere here. Yeah?
Are you hungry?
Kinda, yeah.
Do you want me, boss?
That'd be nice.
I'll cook.
Okay, thank you. What's going on here? Oh, that doesn't work for... Is it like that? No, that doesn't work. Oh, you can't do tuples. Oh, you can't do that? Oh, sorry, I have this backwards. I am dumb. Okay, yeah, like that. That should work. 0, 1, and 2. Yes, okay. Parse error. Okay. That should work, and then I can just delete that. And so we read that many items, and when referencing the primitives, then that means we want to, I guess, yeah, that's fixable in the model. And when referencing the primitives, we want to divide by stride. Yeah, so when we get the slice here, essentially we want to just split everything by half. And assume everything is aligned. Yeah, so you just want to divide by that. So we can check that here. Yeah, let's do it's like a divide by stride thing here. So in the primitive, where am I? Here. In the primitive, yeah, I can just add an impl here actually for fields. Panic doesn't support, doesn't work in const. Oh, it doesn't need to const. There, we have adjust index and adjust range. And so we can call those here. Okay, and this also needs to be using... Oh no, these pointers would be fine for range I. Yeah, those are fine. Let's put this back. For pointer types, they do look like that. However, do they look like that? No, actually, if we are using pointers... No, all the pointers are going to be like... Yeah, all the pointers are going to be using the I types. So, I guess it should be adjusted here too. Okay, like that. Yes, that works. Okay, and then count would be like adjust hold on, count field is a count. Yes, it's offset. And then for slice, we would do the same thing as adjust range. Okay, that works. And then for the single ones, it would be the same story here. Okay, that should work.
Hi.
Art mesh fields. Did I have an art mesh that is errant somewhere? Ah, this one. Yes, it's an end.
A bit.
Okay. Hi. Oh, that looks great. That's amazing. It's like the IKEA ones.
I mean, it's from IKEA.
It's from IKEA.
Frozen
Oh,
ones.
I didn't even know we had frozen ones.
They do. Taste the same. I bet that's
Thank
how
you.
they make it. Very hot.
IKEA
Let's
meatballs.
take my class. Bye. Super hot.
It's hot. I like it a little bit.
Okay. Don't forget to eat.
Okay, we're getting somewhere. So now we just have these. And okay, what happened here? Iron from map found. Macros. And 193. Did I mess something up here? Yes. What did I do here? Oh yeah, I did something dumb here. Okay, good. And now it's just complaining about that. So I think the references are going to be correct now for the vertices, which means now we can in the model, vertices is just these need to be divided by 2. Actually, you could just have a range thing here. I can just have like a slice thing on the primitive type on fields. Yeah, here, like. Yes, and we shouldn't even have this adjust eye range thing. Those are always on, yeah, like in raw type, so we don't need these. And you can just say self dot values like that. Yeah, that works. And so then, actually, adjust index could even do, it can even do the conversion, actually. We can do, get index, like, yeah, we can just say the index is like, is the I, and the returns on a U size. Say dot 0. Yeah, that makes some sense. And so then, adjust range or just adjust index or range of I. I get range. And get index. There, this now makes some sense. And so then in the I range stuff here, we don't actually convert anything. We can just leave these as is, as I offset count, because these types are the ones that we are considering as ranges inside. And then this count one, though, we probably want to return. And here we did just get slice of our thing. we can just call range field here. There, okay. And so then and just count or something like that. And just say let's get index and and so then that count one, I probably want to maybe even remove this because I am a little worried about this. So let's just try commenting this out for now. Yeah, that works. And then this one should only be implemented for ones that have... I guess it is an adjust index, yeah. It only should be implemented really for the ones that have a... that don't have the stride thing going on, but I guess we do need an adjust I. No, not an adjust I. We just need a... This can be returned as is. Okay, am I missing that count anywhere? There's count key points. Yeah, I do need count key points. I guess we do need to adjust count there. Okay, and now we're back to those complaining in the model. So F32 for you just I used chord as the name for that, I think. So in model we can just return chord here. We say chord chord, and also in the just those actually. And in model, say chord. There, now we have the warp form vertices, and for the art mesh should be the same story. We get sliced like that, and so that should magically do the right thing. But this vertex count actually should be let's get F vertex count, which is the raw field because yeah, and we should use the same name test. In classes, there's vertex count and VTX count. Let's just call this vertex count. There, now we have the text chord buffer, and so now the renderer can use proper types for this. Yeah, so now we can fix this mess with the ×2 and all that. So we don't need to specify these anymore. Vertices is form vertices, and then we can literally just cast them, I guess. And then this vertex count is now wrong because it needs to be adjusted. Okay, yes. So now we have the count there, and now in the render we can do the position stuff. Where are we? Okay, now what did I break? Unaligned index, vertex chord, okay. I think I'm probably dividing somewhere where I'm not supposed to. Let me look at the Python again. Actually, vertex count on deformers is oh, okay, so the counts actually do have yeah, okay, so the counts are not actually those aren't actually in the wrong units. So actually the count it was fine in classes here in model. So that one was okay. So we don't need to adjust the counts. I got that wrong. So we don't need a get count. So I guess it's really this declare index types that should be doing the stride. And we can do that in, I need some types here. The offset is, yeah, that's done here. So we need a const. Let's say equals 1. And have the stride like that. Let's just put them both there. And I hope this stride thing works here. Maybe it doesn't. I need a paste. Okay, and so then there's a get count in here somewhere. So this is just count. No need for anything special. And so this deals with the offset automatically. What happened now? Index of bounce. Then is 8186, but the index is 8186. Now I'm just getting confused. 0 times 2 somewhere here. That shouldn't be there. So this panicked in... It panicked in slice, coming in from calculate 367, so here. I don't have the logging stuff here. Okay, whatever, just print line. So actually, most of them worked. And then it died. Hold on. Oh, okay, because I resized it to... yeah, divide by 2 there. That shouldn't be there. Okay. Okay, and we're back to it working. So, let's format, save. I'm going to take a very quick break. I'm going to eat some food, and then we'll come back. I think we're ready to get the model actually laid out properly. We have all the data where it is supposed to be. So, be right back. Okay, I'm back and I ate something, so now we're ready. Alright. Let's go get the deformer stuff mapped. So let's go back to the calculate stuff. The driver. So we call collect the deformer. Now we have the deformers. We can look them up. So looking at the core, we have a deformer. And we have the deformer data here. So you can check if clean. If D done clean, just return. And now we need to calculate the deformation of the deformer. So let me think to myself how this worked again. You want to do the parent deformers first and then the child deformers. So if a parent deformer changes, then the child deformer has to change also, which means this should return a bool. That tells you whether the parent, whether the chain of parents is clean. Because if the parent is not clean, then we are not clean. Does that make sense? Now, hold on. If you modify a deformer, we need to make sure we invalidate all the children. But we don't have the children. The tree works from child to parent. Let me think. If we have, how do I want to do this model? Essentially, we calculate the parent. If the parent changed, then we have to recalculate. I guess maybe like a checked. A clean self and clean branch, right? So, if clean self that means the current deformer is fine, and so basically on every iteration we're going to clean all the branches, right? So we do for D in self deformer dot how do I do iter mut, that is mut. So you reset the tree, the deformer tree like that, so that every time you drive the model, the tree is rechecked. And then if we have clean self and clean branch, then we don't have to do anything. Then we calculate the parent. Actually, let's say if return true for changed. How do we get deformer parents? Deformers are supposed to have a parent. Why don't we have a parent? You forget that. Macros, classes. Deformer is supposed to have a parent. Yes, parent. Parent self. And deformer. And we implement that in model. Part it's not done for parent. We should do that. Right, this is the option PM self. Wait, hold on. Part. Okay, so then in the former here, in the mod, we'll break it up later. This is the state. That's not what we want. This is the model. Which is the former. Let's call it ST. ST dot clean self. So if there is a parent, we grab the parent. Is to return true for clean. And then, yeah, the borrow checker doesn't like us. Yeah, you just have to keep looking at the state like that. Actually, we just want to say if it's modified, clean branch is true, and clean. Change goes that. So if we say okay, yeah. So if a clean self and clean branch return true, otherwise, check the parent. If you have a parent, say false. Actually, makes more sense. For changed, if we did not change, then if the parents did not change and self is clean, then return at this point it's return true for changed. Otherwise, we do the calculation here. So what we do is we have to take the deformation of the parent and basically need to call on the parent. You have to have like a deform function. So first we would need to, okay, the way this works is first you interpolate the forms, and then you deform using the parent deform. So first we need to interpolate the forms, which means we need like the parameter values, which you don't have. Let's just get the default form for now, as we did for the rendering, because that way we can get something on the screen. So we're gonna just get the default form. Hey, Martin, thank you so much. Oh, I'm so sorry. I did not press the button. I am silly. I am really silly. I'm so sorry. I was supposed to press a button twice, and I only pressed it once, and I am really silly. I'm so sorry. I'm so sorry. Parent, look up. Thank you for the super chat for letting me know. I need like a notification system or something. Parent, look up. Okay, so let's just get the same thing we did for the art mesh here. The this neutral form thing. Actually, no, parent must returns an iterator, which is a little bit annoying. I guess we need... Okay, whatever. Let's just copy and paste. Okay, so if we have a rotation deformer... we need to... Okay, so let's get the indices first, get the vertices. It's not art mesh, this is deformer. So if this is a... hold on. If this is a rotation deformer, we need to calculate the affine transform. If it is a warp deformer, we need to do the grid stuff. So I guess we basically need an apply deformer that applies deformations to vertices. So apply deformer. And in the state, we need to keep the... essentially a copy of the form. Which I guess this would be... we need two different arrays. So this would be warp state and rot state. So those could be implemented differently. So warp state and rot state. So let's put some parameters into here. Rot state is basically these are basically going to be like a form, right? Just possibly with a slightly different data model. So warp state needs to have a vertex array in 2 dimensions. It's kind of points instead of vertices. And that's it really for the warp. And for rotation we need a bunch more. For rotation we need I guess you also need the multiply color and the screen color. I actually don't know how you add, like, do you just add screen colors? I guess you just add them. I'm not sure if anything else makes any sense. So for rod state, we also have an opacity. I guess for rotation deformers, I actually don't know how they interpret the flips because that's kind of weird. I don't know if they just I don't even know if that's supported. I guess we'll figure that out later. I can skip the flips. But I need to yeah, okay, so the interpolation for the rod form cannot use like a standard transform because it's supposed to be a rotation, but the actual transform can just be a matrix. Does Rust have this is where I need a Rust matrix math library or something like that? I need something simple. There's no algebra. Now I need something I can just do like some basic you know, 2D, 3D. Matrix math. Glam. Yeah, this makes sense. Simple and fast and library for games and graphics. Yes, that's exactly what I need. So origami file, cargo, add glam. Cool. And so then I guess I might as well use like these types for this. Like Vec3 and Vec2. What happens if I just do I guess I could use a Vec3 for oh, Vec3 is like aligned. Interesting. And that means that it'll lose a lot more memory though for vertices. So that's not really what I want, but oh, but Vec2 would be aligned to 2, so and then there's a fine too. Yeah, that makes sense. For color, I guess I could use Vec3. But I'm not sure that's a good idea. Okay, so let's see if this compiles by changing the type. So rod state is basically an affine transform at that point. Affine 2, matrix 2, and translation 2. Yeah, that makes sense. You can do like a from, yeah. Oh, that's nice. You can do a from for vec3 and this kind of stuff. So, that makes it easy to convert these types. Okay. So let's just do that. And where are we? Huh? Warp, rot, default. Okay. So I guess we need like a calc warp and calc rot type of thing here. Or I could just have the state have... Yeah, actually, I could just have it in a single array and then the former hash UID. Yeah, and then the former state. And then just have it, like, remember which type of deformer it is. Yeah, that kind of makes sense. So that way we can just have deformer state, clean branch, and T, whatever. Warp state. I can just do that. And we just need some defaults in this. Actually, we don't even need default in that. We just have a option. Former substate. So calc deformer can just do that, and then we do the lookup. So actually, I think I can just kind of clone it. So if it has this clean and not self and true, then what I can do is just say let mat st equals st.clone. So now we need to recalculate it. So we can just have a clone of the state, so we don't mess up with the we don't depend on so drive clone, but not copy for these. And so then I can just take the state. Actually, do you even need to keep any state? No, we're just going to create a new state. Yeah, we're just gonna create a new state. There's no reason to use the old state for anything. So we can just say if the former dot say match even match the former dot typed. Like that. And so this doesn't need to take a mutable reference to self because it's not going to mutate self. We already know we have a parent that is not, yeah, so apply does not mutate anything. Self, model, T. And the way that was done in core was, yeah, just the warp deformer. Let's call this warp. Returns a warp state. And so then we can actually just have the parent maps here too, or use the parent for that. Because it actually does have those, the form does use that. It does have them in the file, so we don't verify it now, but we can add those. Special parent maps. And it's not T warp deformer, it's T deformer, and then we had a subtype for warp, I think. Yeah. And it would be a warp ref. Can I just be a warp pointer? So this is calc warp. And then we need a calc rot. Rot state. Rotation. Okay, so now we need something to interpolate these things. Well, okay, we'll do that later. Let's just get the neutral one, get the form. This is warp dot form, neutral indices. And then for warp, it's vertices. For rotation, it's other stuff. And apply deformer, we'll figure that one out later. Okay, good. So for calculating the warp, opacity form dot opacity, affine would be form dot. I'll figure that out. Multiply color would be form dot multiply color, and screen color would be form dot screen color. So this is rot state. Whoa. This is rot state without considering the parent. We start with the untransformed state. So for affine, how does affine 2 work? Affine 2. It's just matrix 2 and translation. So there's probably some, yeah, from scale, from angle, from translation. Yeah, from scale, angle, translation. Yes, that's exactly what I want. From scale, so you have scale, form dot angle, form dot position, and scale is vec2 splat. This is the same on both. And translation is a vec2 position. Sorry, a chord. Oh, yeah, I need to fix these. And just do into then. Yeah, because it'll do the right thing for that. This is the only one that doesn't work. Even though they should be compatible. I think I just need to change the... using classes here when I did the vertices. If I just say core chord, it should work. And the same for text chord. For opacity, the same thing, and the colors. So now, for applying rotation, it's actually a funny thing we do. We'll do that later. Let's do the, let's do that. Let's do apply deformer. So for apply deformer, essentially we apply deformer to a vector. So then for Kakarot, we have to get the parent. If that's some parent deformer parent, then we would do oh, we don't have the parent here because they're passing rod directly. I guess we can just use the former here and then unwrap. It's that warp. And let's just pass both actually. there's no index mod and hash mod. Okay, I need to get mod. Okay, yes, I thought. I just use insert, I guess. Oh wait, not new state. This is sorry. It's a lookup and then we change the sub. There we go. And I can do an impl here for the apply actually. So on the former state, I can have an impl the former state and apply self. We don't need a model. We actually only need chords. A vec of chords. And this would just say match self dot sub and then we just match sub. And so then in rot state and warp state, we can implement the same thing. In rot state, do that. In warp state, apply. So for rot state, it's easy. We just apply the affine transform, which is probably a very simple function somewhere here. Transform 0.2, yes. So what do I do? It's like a map mut. Iter mut. And I guess just need the opacity and multiply color and screen color. So, yeah, we need like a visual state, right? So you put these in instruct visual, and then we can like multiply them and stuff. And I guess we're gonna need a default for these because we're gonna be generating them anyway. We just need clone and debug. So for apply, we apply on coordinates and on visual visual. And the visual should also have visible bool, I guess. And visual can also have an apply here. I guess these colors should really be a Vec3 at this point. How does Vec3 work for multiply? Is it just regular multiply for element-wise? Okay, yeah. Null is just element-wise, which is what I want. So then for the coordinates, we would iter mod and just to see apply find dot transform or something. Hold on. Coord itself dot rot state is affine dot. This is not doing what I want. Affine to transform vector 2, transform point 2. What's the difference? Okay, point to enter translation, yes. Okay, apply math is what I want. Okay, that's not a thing. Maybe not. Hold on. Rust. No. Rust. Apply closure to each vec element. I can think I can just collect the iterator in some way, but there's some application stories. Yeah, so yeah, but I don't want to collect. I want to like discard? How is this? There has to be some way of you do iter much for each. That's how it works. And that's how you do it. So for rod state, we just do that transform to. For warp state, it's a little bit more interesting. For warp state, it gets very interesting actually. So for now, for warp state, let's just say we don't warp anything. So there's no warp deformers, there's only rotation. And for rotation, the way we chain those is actually interesting. So if we have a parent here, actually this needs to be visual. Put these in here. The deformer has a visible thing, I think. So the way the rotation deformer apply works is actually really silly. What you do is you take the... Look at how silly this is. You do a vec2 and then a vec2 of... I need to do that. You transform those 2 points. Which means I just need to look up the state. Why is it mutable? Hold on, lookup should... Oh, because lookup can mutate it if it isn't insert. Okay, I don't need lookup. I need a... At this point, we know the parent exists. So, and just do get unwrap, or even just index. That doesn't work. Okay, never mind. Get option. Yeah, that works. Unwrap, and so then, oh, whoops, that's rare that that happens. Just had a little audio issue. Then we transform these 2 points, as silly as that is. And then we use that transformation to modify our vector. But we don't scale. We only use the angle and the... I think we don't scale, actually. We only use the angle and the position. I think. Which essentially means that... oh, by the way, I need to check if the angle is in degrees or not, because this is probably possibly not in a fine... doesn't say if the angle is in... Map 2 from angle. It's radians, yeah. I need a radiance conversion function. Is there a radiance thing? No, not here. There's no helper here in Glam, right? I assume there's a pi. It's the F64 constants, okay. Is there an F32 on that? Yes, okay. What? Constants. And I can just do, just have a radiance function in here. Oh, I think it has a reduced radiance. Where is that? I did not know that. It says 2 radians, okay. I did not know that. That's convenient. So we don't need pi then. And so then we need to just calculate the angle of this. So how do I do that? There's probably something in Glam for getting the angle. Does Glam have like simple vectors? There's quaternions from axis angle. Okay, hold on. I think I can just do, okay, let's just do it like this. You apply to the point, and then we just say self dot, actually just st dot, affine dot, and we can just first translate it. There's no way to translate it. You have to multiply, I guess. Okay, what are the conventions for this? I guess it's mullet sign. And what I want is from angle translation. And so the angle would be, it's going to be interesting. And the translation is P0. And so for the angle, I need to get the, well, it's not really from angle, it's from, like I basically have a vector, a rotation vector that I need to, apply. So for rotation, actually, I don't even know if the rotation angle is the right direction here. But for this one, what I need is, So if I normalize it, we'll have minus 0.1 on the y direction, and I basically have to flip that into x. And then I may or may not need to transpose it. And then what do I do for the rotation vector? Ah, there's angle too. That would work, yeah. Okay, yes, and then I can choose angle. It would be P0 dot angle 2. And then we're gonna have to like adjust the angle there somehow. So, what's the convention? The convention should be probably that the angle, it says the arc cosine. Because the coordinate system we have here is actually x plus horizontal, y plus vertical. And to not confuse things, I kind of want to keep that, but I don't know what Glam is using. Hold on, Rust play. Can I use the Rust playground with like crates? I'm not so sure. Maybe not. I'm not sure if you can do that in Rust play. Probably not. Yeah, how do I... if it rotates to the left, I usually test this. Let me just do a separate thing for testing. Oh, right, hold on. Huh? Oh, that issue again. Okay. So I'm pretty sure the okay, that's a Nyan. Why is that a Nyan? That doesn't make sense. Oh, both of them must be non-zero. Hold on, what's angle 2? Oh, that's between two vector angles. Okay, that's not what I want. I need a I think it's just angle for vec 2. Oh, I guess you get the original one and then you can do angle. That makes sense. Oh, there's two angle. Okay. Yeah, so you get something like that. And if the point moves to the left, the angle decreases, so it's the opposite. Okay, so that's 0. And if I make x larger, then it should rotate positive. Yes. And if I make it negative, it should rotate negative. Yes. Okay, so this is perp to angle. That's how you calculate that. So, so that's the math for getting the angle for a rotation deformer. That's the funny calculation that they use to interpolate. Okay. You know, this will actually already give us a lot for the model. Because ignoring warp deformers, that is all we need to calculate model positions properly. So now we just need to go through the art meshes and calculate the states. So if there's a deformer, we calculate deformer. We need to get the steal this from the render, the neutral indices, get the form, get the vertices, and so steal that. So you get the vertices. If we have a deformer, then we just do self.apply deformer. Actually, we just need to get, you already have the deformer, so we can just do, screen color, multiply color, opacity. Yes, we do have that. ArtMesh.visible, get the visual, and then we apply to the vertices and the visual. This needs to be a vec. Hold on. Expected vec. Yeah. Apply should be, you should just take a slice actually. Why am I using vec there? Make, mod chord. No need for vecs here. How do I do slice to vec? It is 2 vec, right? Yeah. There we go. Now we drive the model, which means we have all the art meshes. And that returns the driven model. And in driven model, so we need to apply these art mesh states somewhere. We would like to use the what I didn't render for the vertices, this kind of deal here. So let's actually do that in the driver. So in driven model, we can have the driver, the model, and we need the vertices for the art meshes. Or it can just be here, actually. So you basically just copy this into the vertex. You can just say VTX off office artix export offset. So we just say form vertices equals form.vertices. Offset is our mesh text chord offset. And it would just be driven model as driver, vertices, the former art mesh, yeah. Art mesh, vertex count. Let's go V buff. Okay, so you just make a copy into the VBuff. I think that's probably a slice assignment thing we can do. This might just work if I just do this kind of thing. Not sure. No. Let's use some copy slice thing we can use. Copy from slice, yeah. Yeah, there you go. So you can just copy that from the form vertices. And so this will just see self vertices precise to the model text chord buffer. There we go. Just apply to the vertices on the art mesh. So then we have an issue with the state being borrowed there. I guess I want to just do this first, and then before I borrow anything. Oh, but I'm doing a mutable change on the vertices. Nah, I'll just create a new one, actually. Let's vertices. And then vertices not resize, and just assign to self. Or even, I could just take the vec. Yeah, I can just take it. There's a take function, I think. Or maybe not. There's some way to take the vector though. I thought there was a take. Ah, you can do take, dest, mati. Yeah, okay, you can do take. Yeah, you can do mem take. And then we can just reassign afterwards. There, that should translate all the art meshes. And so now we just need some, maybe some stuff in driven model that we can use to get functions out of it. Driven model. And we need an art mesh state. So we have those. We need to update them. That needs a visual. And I guess those don't have a default. It does work though. So for the visual, we need we have this, and we apply the state, and then we just commit it to self art mesh dot insert art mesh dot uid comma st. And we can just make these public. derive default. The T default problem. Yeah, that doesn't work, but it doesn't. Yeah, okay, never mind. And then we just need a getter for the art mesh state, and I should have an in the art mesh state we should have an index for the a base vertex in there, which is the same as the text chord. Art mesh text chord offset as usize. I think my SP is being silly again. Or not. I have another syntax error somewhere. Something's wrong. Build. Oh, what happened there? In driver mod RS. Not sure what happened there. Okay, vec2 does not have a read array. I think that's just the transmute thing I need to add in here. This doesn't work for vec2 transmute mut. That is annoying. Is there some kind of view that converts things back to from array? No. Slice. So from angle. There's an asmut that works for a single one, but I need something that works for array. maybe we don't have that. I might have to use unsafe for this. Okay, I'm gonna take a quick break. I'll be right back. I'm back. Okay, so this is easy enough then. We just need to it's unsafe and pin, thank you. Okay. There has to be some way of doing that. Maybe on GitHub I'll find something. Ah, there's a single copy. There is a flag for that. There is a feature. Here we go. Add glam F0 copy. Nice. There we go. Now it works. I expected that. Because come on, everyone needs that, right? Okay. So now now we have the art state base vertex visual. So you can have vertices and you want like an art mesh state. And I guess that means we can just make these things. Not a art mesh state, more like art mesh view. Let's make a clone of this because I don't really want to driven art mesh. Base vertex, visual. It's got art mesh. Driven. Art mesh. And I can use the lifetime here. I'll just put vertex count in here. Just it's kind of redundant, but it's a little useful. Okay, what happened to the SP? Why is the SP being silly? None depends on items. What? Why? Why did that break? No, that did not work. Where is the LSP server? Why is there no server path? Why did this break now? I mean, the server runs. How do I get like a Python backtrace? Is there cargo on top of that? I think so. Can I just like run Sublime from the console? No. Maybe it's because I have like too many things open. Like something is open here that shouldn't be open. If I just close this window and start everything again. And this is all, I think, because of the... No, it's still broken. Wait, what's this thing? Is that what happened? No. I have no idea why this broke. No. Come on, this is so nice. How do I get a trace back of that? That's just rust analyzer. Okay, how do I get like standard output? Sublime, text, Python to the out. There has to be some kind of window for that. Huh? There's a data log folder. It's not enabled. Okay, how do I do this? Come on, there has to be some way of doing this. Why? Lindex plugin log. Everything's for looking at logs. Oh yeah, troubleshooting. Hold on. Okay, preferences of these things. Log debugs. Okay, I need that. Let's try that. Nothing there. No, the Sublime broke. I don't know why.
Oh no. Still broken?
Yeah.
Still broken?
Yeah.
What happened? You got
Like the like language server is like throwing a Python error, and I have no idea where this is coming from.
Did your stack overflow?
I don't know.
Oh man, that's
Is it view? Is there a show console? Here, show console. Okay, there it is. At least I know what it is now. Collection, see in items.
Are you still hungry? When
I'm
do you
good.
eat food again?
I don't know.
No? Okay.
Legacy settings. That did not work. Oh, because it's probably like precompiled or something. Oh, there's like it's a file. Right, it's a zip, okay. Okay, so legacy settings, is null, is none. What is this none? So is this a config setting I have? Context configuration settings get Rust Analyzer. So I messed up the settings somewhere, I guess. There's some kind of settings file that got corrupted. There's something here. So it's supposed to be a Rust Analyzer, in context configuration settings get. Wait, hold on. I think I know what happened. I think it's because this is... I think I just need to remove that. Oh, I think it's because... Oh, I think it's because something got updated. The plugin probably got updated and something changed. And there's like backwards config that is not working. I think it's because something got updated. Nope. I'm just guessing here how some of this might work. Nope. Hold on. So this is using context and tracing settings, get Rust Analyzer, legacy settings. Why do I always get the silliest problems? Init options. See, this is it's this legacy stuff. I used to have it like that. So this was changed. Hours ago, prioritize legacy settings. This is literally 15 hours ago. It's a change from 15 hours ago, and that's what broke it. Come on. Can I just downgrade this somehow? 15 hours ago. Thank you. And it's gonna find an issue. How do I downgrade? Yeah, it's Python, but it's in like a zip file. I don't know how to undo that. So can I like ban a version or something like that? No. No, it is a separate package, so it should let me downgrade just that one package, I think. Can I install it manually? Possibly. Sublime install package directory. Folders and our data packages. Okay, yeah, I think I can just do that. Yeah, I think I can just link it like that. And then, like, uninstall. And then I can just install it like that separately. Might need to just restart that. Okay, that actually ran. Yeah, okay, so it is running. Maybe I can fix it. Okay, so it's a dotted dict, and for some reason, get is not returning. Oh, I think that dot get just doesn't work. Yeah, something's weird there. Okay, so here's .detect.get. Maybe it's not that .detect, maybe it's something else. Okay, that one's this one here, actually. It's default. It's a bug here. They just do current.get key for keying keys. Otherwise, return default if it's instance current dict get key. So what is self._d? It's just empty. That returns none, that's why. Because it's the last key. Because it'll return none. It's because it's get... No, sorry. Python dict... Yeah, it returns none, that's why. If the last element in the path is the one that doesn't exist, then it returns none. So actually I'll just file a bug and say the bug is actually here. Yeah, okay. Okay, anyway, I'll just fix it by just doing this. Let's see, settings, okay. Just a workaround for that. Yay, okay, permission denied. I'm not sure what that's about, but I don't care. Interesting that that didn't work. Seems a little broken, but okay. Okay, so back to actually getting stuff done. That was really dumb. That was really silly. ModRS. Yay, SP works. Maybe. So, vertex scan view size, driven art mesh. I am gonna make this render today. Self.vertices, base vertex dot base vertex plus self vertex count. Base vertex, vertex count, visual, I guess we don't need the vertex count. Could be useful anyway. And we need a copy for visual. Or just clone, actually. Okay, so that gets us the state for an art mesh. And now in the render, we need the state, which driver isn't here, so we can just say we have the driver. We don't need these anymore. Okay. And so now the vertex buffer would just be cast slice on dm dot vertices. In driven model, where are we? Pub. And we need a function to get the model, I guess. Model. Okay, so we have, let's not do these as struct vertex. It's more like position chord. And these don't have byte muck, but they would have the 0 copy. What's the trait for that? The from bytes. Because I don't think the glee that has the glam doesn't have the feature. Oh, that's not what I want to do. Glam doesn't have the feature for byte muck. Probably. Nah, it says 0 copy. Oh, but it depends on byte muck already, so it might already have it actually. But maybe not. Oh wait, no, there's a byte muck feature. Yeah. Okay, it does work. And text chord should also just be a chord. And so now over here, we don't need to do anything for this. we just load the vertex buffer. Let's call this drive. And actually, I'm just gonna put this on in line because I'm gonna need to use this data. So now we have the state, and the state would be actually technically the vertex buffer could be changed every time, but I'm not sure if I want to do that. But I think it makes sense to possibly have these be in a different format. So vertex buffer and text word buffer. Do it like that. Vertex buffer. And I guess if that's using U64 or base vertex, we might as well use the same thing here. Or just convert. And now we have some borrow checker stuff. Okay, I guess this would be, I need like a self-model, let's call this mdata. Like that. Yeah, it's just MD, which we have. Okay, and then make pipeline is a problem. This is stuff from self. Which should be immutable, but we have mutable. Do we have mutable? Yeah. No, that doesn't work. The way I fixed that earlier was by not having the model data around here. I can just pre-make the pipelines, I guess. Okay. Field point is never used. Yes, we never use that. Cargo run. Where is my history? There, that. Okay, and we panic. We panic on too much stuff. Out of range for snipe, so thing 0 in index mod in driver mod RS 259. Somehow we have. Oh yeah, we need to resize the vertex buffer. Is it gonna work? It's gonna be upside down probably and a bunch of stuff. Okay, no. Unwrap on a none value. At render 409. Okay, we don't have a pipeline for some reason. There's this thing. This has to go first. Okay, there should be error. Offset 74 for vertex. It's not able to vertex alignment. Oh, we need to align stuff. Right. Oh, wait, is it because these are byte offsets? Probably. Yeah, okay, that's probably just why. That's exactly what I had before, so... Not very useful. What happened? Did we not... Did we not update the vertex buffer? Oh wait, I haven't transformed anything yet. Do I? Have I? I should have. Just to see if we can apply, just make them 0. Iter mod for each C equals vec. We just set everything to 0. Okay, so we are hitting that path. So it's definitely doing stuff. To 2 vertices, it says. What about the actual arrays at the end? Okay, now that doesn't make sense. 2 vertices? Why? Why just 2 vertices? There's 48, 39, 36, 54. Okay, so some of them do have it. Oh wait, I know what. I know why this is happening. It's because the okay, yeah, see. It is doing stuff. However, the warp deformers are not inheriting anything from the parents because they don't have that. So, we need something for warp deformers. So let's try to implement that. So for calc rod, we declare the rod state for the current form. Then if we have a parent, we apply the parent transformation using this funny formula. For warp, we get the vertices, and then let's call it vertices too, so it's... Nah, I like points. So if we have a parent, we have to apply that to all the vertices. So essentially we take... we take a copy of the vertices from the form, and if we have we do this warp state, points, vertices, and then we just apply the transformation from the parent. Warp state, vertices. So vec chord. Okay, I need to like reshape those. Actually, no, I just keep it as a single vec because it's a little bit easier. So this should just apply the warp state, and then we need to actually implement applying warp to warp or warp to anything else. So the way that would work is basically do the same thing. So we need to do the magic stuff here. Warp state needs to know about the dimensions of the deformer, since we don't have that. Warp state, where's that? Just go size. And so then what we do here is I'm also need the bool for the interpolation. The bilinear thing. So we need to get the 4 corner points from the warp. So you would say c dot x divided by self dot size dot 0. Do I want to use the utility? Probably. I can just convert it actually. Divs. Vector limit. Huh, okay, need to deref. And we need like a max and min. Does the clamp have max and min on F32? Combine to still clamp. Combine minus clamp value is a min max. Yeah, it's just saturate. Okay, so we can just do saturate. Just for now. And sorry, then we multiply by if divs or whatever. So that gives us the position in floats. And then we say u of x2 dot, is it from F32? No. There's an as u of x2, and it just casts, which is what we want. And now we have the grid coordinate points. So we would say PA equals self vertices, and it would be like this. And then we have the U size there. Okay, so now we have the 4 corner points that we have to interpolate between. And then we would say if self.bilinear then we just interpolate between those 4 points. Is there a... I think there's a lerp thing we can possibly do here. Yeah, you can do a lerp. It's easier to understand. That's how you do warp deformers, the new way. Otherwise, the old way is you have to do the weird triangle thing, which would be if x plus y is not if f bus dot x plus f bus dot y is less than 1. You do the triangle interpolation thing. How does the triangle interpolation thing work? It's like the barycentric coordinates formula thing. But we don't have barycentric coordinates. We have like not deep wiki, why deep wiki? There's probably some good math for this. I guess it's basically a right triangle because we don't care about the screen space output, I think. And oh wait, no, I think you just do. I think it's just a lerp between those two, and then like yeah, I think it's just this. I think this is all it is, really. Otherwise, for the second triangle, it would be essentially the opposite. You just take it backwards in the other point, right? So, and then it would be 1 minus that. Times P11. And this is the other way around. I think that's the formula for warp deformers. Oh, did not work. That's 121. The index is 121. Okay. Yeah, 10 by 10, 121, which is 10 by 11, and then applying to another warp deformer. Okay, so where did it panic? It panicked in at 106 here. Okay. Let's put a print here. Oh, I guess if it's 1 1. Yeah, if it's 1 1, it's just gonna get IPOS equals, yeah, okay. There's no function vector U in Glam? As U vector. It's U vector. It's U32, yes. And clamp is greater than or equal, I think, right? Okay, max is actually... Yeah, okay, it's the max, which is... Yeah, it should be max size. Because if it's a 4x4 grid, then the max is 4x4 inclusive. Okay, let's see if that works. Okay, no, that still doesn't work. Let's print these. Oh wait, isn't it plus... If the vector is 10 by 10... Oh, and then I also want to limit that, yes. Yeah, so the issue is something is larger than the deformer in this model. because it's 10 by 10. Yeah, so there's something exceeding the model dimensions. And so if I do it now, it should be clamped to 10. Yes, and then I need to clamp this to one smaller. Well, we got something. This still has something very broken, and the terminal is very unhappy with me. Let's not print that. So, a lot of these look good in terms of the vertices being in the range that I expect. So that looks pretty good. One issue is that the art mesh is not being drawn in the right order. I can at least just look at the draw order stuff for now. So let's do a very quick hack on draw order, even though this is not correct. In file, we can go to in classes. We have the draw order stuff, draw group, draw item. We can just ignore the draw groups for now. Just draw items in the same order as in the file. Let's just have a hack for that. So if we have core, yeah, this is gonna be a hack for now. I just need to get an art mesh out of this, so and for art mesh, it would be item ref. But it's a little weird because we have that. Yeah, it's different art mesh. And it's not PM art mesh. It needs to have the actual thing. It's really this type deformer thing all over again if we want to do it right. Is it really I art mesh? I forgot. It's either an art mesh or a yeah, I think this is wrong. In classes we have it's iChild for draw item. And this has to be again a U32. That's wrong. F item type, and we need some types of URF. Yeah, this needs the impl thing. Impl deref, blah blah blah. Yeah, this thing. Where is this core stuff art mesh? I think this is the VM option art mesh. Hold on, where is that? No, it's option. Yeah, it's option PM. Yeah, okay, that is correct. It's option impl direct target equals dollar type. The console is very slow. I think it really doesn't like when it has a lot of scroll back. I don't know why the macOS console is so slow. Yeah, now it's like really slow. I have no idea why it's so bad. I can't quit terminal? What? For the former view, what? Oh, did I just copy and paste everything? Yeah, okay, I'm just done. Oh, okay, this just needs a star in there. Oh, because this is already an option, right? So you can just do that. Okay, there we go. Missing draw items. Yes, there we go. So now we have draw items. And we should be able to just get the art meshes in that order and at least get them right. Iter, enumerate, we don't need I, just want art mesh. Let's take draw item and we say let art. Art mesh unwrap. No enumerate. Okay. Woo! Okay, we have something on the front that is breaking everything. I kind of want to print the bounds. How do I do a min and a max in glam? How do I compute a mean across multiple? Land doesn't really have array types. I would like something that can actually do arrays. That would be nice. But I guess that's not a thing. Okay, I'll just do it manually for now. So where are my dishes? Okay, there we go. Most of them on this -1 + 1. Some of them are not transformed. And yeah, some of them are being transformed. Let's look at what the tree looks like in Python, and that'll probably tell me what the problem is. So for example, 147 is not transformed. Right, so those are at the top part. And what about the deformity? They do have deformers, though. They have rotations and then a warp at the top. And the rotations are supposed to have the scale, rotation 2. So this is where we are losing the... We're losing the transform. So in deformer here, I probably just have a silly thing where I miss. So calc deformer. We can just do it here. And I need a derive debug on all these things. Not here, sorry. Deformer UID cannot be formatted because... Yeah, I think I just need to put... Put this plane there. What happened here? Art mesh. Rot state. So we're looking for rotation 3. Okay, that's not right. Oh wait, no, because rotation deformers do apply the scale from the parent. Do warped deformers do that though? Yeah, we're not applying the scale to the child deformers, but we need to do that. I just don't know if that actually happens for mesh. It kind of makes sense for it to actually apply though, because otherwise how would it even work? I get tested with VTube Studio. I guess we need to do a little test here. Let's go back to the testing thing. So in here, have the test rot. And then I broke that at some point. And I am missing something here. I need to print something on the builds. What form I multiply color? Required is not an integer. Huh? Because I added those later, I guess? Or messed something up. Oh, because yeah, these default to none because there's no, yeah, okay. Just default to 0. Okay, fine, we'll add them. Count struct build because we changed the counts. And then there's no object counts for version 5. Because we changed the, yeah, okay, so, I should fix that version problem we have. This is back when I thought the version number could be too, like major minor, but it's not. So, this should just be in like that. Build counts. Huh? Oh, right. How did that ever work? Okay, that works. Is Vita Studio gonna like it? I am leaking. I'm not supposed to show that. I'm not supposed to show that. Pretend you didn't see that. That was not supposed to be there. Okay, it doesn't like that model, and I have no idea why it doesn't like that model. This is gonna be annoying. Python Mach 3. Is there any validation errors on this one? Yeah, okay, unit clips. Deformer. It complains about what does it complain about? Possibly the key point array sets or something like that. Hold on, deformer. Oh, it's the former parent order. How did I do that? Okay, that works. Does not like that. Let's try without deformers. Nope. I don't know if it supports an empty model. Would have been nice to have, I mean, I guess I could use git log here, but... what is this self-erase thing? Did I get something wrong in the, just make sure it's not something dumb. No, wait, that's not working either. Why is that not working either? Is my... Is my Read of Studio directory correct? Yeah, that's right. Okay, so that one does work. Okay, so it is broken. So that structure looks fine. This looks fine. But there's an alignment difference. Counts. I have the first one at 9C0. The original has it at... Oh, wait, no, it's because there's different offsets. But it is different, so something's wrong here. The sizes count is not aligned the way I expect it to be. So this is ending at 880 instead of 800. And that doesn't make sense because we had we're supposed to have more object counts then. Where did I mess this up? Sizes. The counts have to be wrong. So it's like text. Maybe there's more counts that I don't know about. What does MX say? Oh, yeah, there's like extra padding there. That I don't know about. So it's probably just that. Add section, build, plus, just add some stuff there. Ah, there we go. Now it works. Okay. So it was just that. Now, let's turn those rotations again. Rot 90, rots viz, the former parent. Okay, I think a very quick break. Be right back. Back. Okay, I think I'm really close. You just need to figure this one thing out. Translation X, what's going on here? Don't print it. Okay, so now this is there. And now if I deform that. that happens. And if I make it much larger, okay, see, that's interesting because the rotation deformer is not using the size of the warp at all with that vertex. So what about if I make it larger in general? It does not affect it at all. So that's very interesting. Yeah, it doesn't affect it at all. But now, the question then is, what affects that size for that warp deformer? Hold on, what is the original tree in here? Okay, we have a warp, and then we have a bunch of rotation deformers, and then an art mesh. So the art mesh should be getting resized by this one, even though the warp size doesn't matter. So that's not the problem. The problem is something else. Okay, so rotation 35, for example. Now, where are we? Art mesh 147. Is deformed by rotation 3. And so rotation 3 is deformed by 23. So about 32. Yeah, that has no fine. And what about 2? Okay, so we're just not changing rotation deformers properly. Rotation 32. Oh, okay, I get it. So if a rotation deformer is a child of a okay, it has to check who the parent is, basically. Okay, I see. So we need to special case that. This funny math, the 0.1 hack, this only applies if the parent is a warp. Otherwise, we can just use the regular affine multiplication. So, If it's a warp, then we just multiply the affine. So if it's a rot. Otherwise, we do this money thing. Okay, I think that's something. And now we run the code again. And it's broken. Okay, what happened now? Okay, rotation 2 has the right thing, and then rotation 32. Okay, now we have a chain of deformers that makes sense. Now these are actually getting the right values. So what ambitious are giant here? Still a bunch of them. So where's 147? It's here, okay. -15 -69 -69. That's weird. So it's like still off. Art mesh 147 should be deformed by rotation 3. Ah, this translation is weird. Okay, hold on. So what do we have here? The translations are off. So if we're looking at rotation 2, for example, just here. It's possible we have translation in the wrong direction to rotation and scaling. Rotation 2 has the right size and translation is 0.24, 0.5. Yeah, okay, that's translation is correct-ish. then rotation 32 is supposed to have roughly the same translation. So why does it not? Okay, let's add a print to this. Okay, rotation 2 says it has before of translation minus 179.55. Sorry, that's for 32, I think. Yeah. 32 has where did this translation come from? I don't know where this translation came from. That's weird. Do I have the wrong vertices for these deformers? Okay, let's put this form stuff in here. Okay, rotation 32 claims to have scale of angle 4.9. That's not right. Index 1? What? No, something's wrong here. This is not right. Rotation 32 is specified. Angle of 0, scale of 1, and translation of 0. And it's rotation 2. It's this one. It is form 1. And yeah, so where did that 4.9? Okay, this is... We got the wrong form. We ended up with the form at... Here, 180.55. Yeah, okay, so we ended up with the wrong form. We have form index 1 and we somehow ended up with form index 2. How did that happen? Oh, wait. What's the step plus indices 1? That doesn't make any sense. Step times indices 1. Oh, there's a bug. Okay, now it's still broken. Okay, now that looks good. Angle is almost 0. Position 0, 0. How do we get a translation? Because the parent has a translation, okay. Then deformer 6 has... Okay, we are applying these wrong, right? The application order is backwards. Which makes sense given kind of how that works. And still quite broken. So you go to deformer 8, for example. This one looks right. Okay, so what art measures do we have? Okay, these actually look much better. And some of them are wrong, though. Okay, so what happened to, for example, ArtMesh 65? These chain off of a warp deformer. Warp 16, okay, that doesn't look right. You have a rotation deformer that it's not scaling right. Is it because we need to go back up the chain? Like, these translations are large. This is still big scale. Then this is a warp deformer that is tiny. Oh, now I'm confused. Okay, here's a warp that has very big X and Y. Which makes sense, because then that would deform the warp 8. Okay, so what happened here? Right, so if you have a rotation and warp and then another rotation, what coordinate space is the child rotation deformer using? Okay, this is a little weird. Then this is not quite what I expected. I need to do another test. Scale to X, translation 0, 0, angle 0. 2.0. Okay, that scales everything up. This is still moved there. And what if I change to warps? With cancelled out dimensions. Okay, that is very unhappy. So this made the inner warp much smaller. Okay, I think the way to handle this is that warp deformers will carry a global scale value that is inherited from rotation deformers. And then we just propagate that. I think that's the reason why to do this. Because it's not using the scale of the mesh itself. Like, for example, if I make this larger, yeah, see, it's always in the right place, but the scale is ignored, and then the scale seems to just come from the parent deformer. So if I increase the scale of the parent, everything gets bigger. But still looks the same. Yeah, okay, so it just has to be a separate scale value, basically. Weird way of doing this, but okay. So, therefore, what we need is to keep in the former state here. In rod state. sorry, in warp state, we keep a scale. And so then when we have a warp deformer, we will take the from scale angle translation, from scale angle translation, and we would say, SNAT, W dot scale. And then we just need to preserve that across the rotation deformers. Sorry, the warp deformers. I guess we could just keep the scale outside the deformer type to make it easier. So for warp state and rod state, we keep the scale outside in deformer state. Maybe I should just use the traits. Hold on, go back. So now I just need the calc warp. Let's just have the scale here, I guess. Now, I can grab the scale separately. Yeah, okay. So we always multiply the scale, and then if the warp case, we take the scale as part of the affine, and then that's for rot. And for warp, we start with 1.0, and if there's a parent, we apply the scale. Okay, that might work. Why is Live2D so strange? Still broken. Okay, now this is looking good though. All these heart niches are... They have the right... Oh yeah, no they don't. What's going on now with 163? Let's print some more stuff. Fine. For example, these are childs of warp 120, which is a child of rotation 57. And that has not changed properly. Rotation 55 is wrong. Rotation 54. Did not end up with a nice scale. Okay, so rotation 17 has a scale of 0.001. Then warp 99 Oh, it's actually just rotation. Okay, so that one has a scale of 0.005. And I assume that's just rounded. Then warp 99 ended up with a scale of warp of 1.001. That's not right. Calc warp. Oh, times equals, not plus equals. I keep making silly typos. Ah, okay. Let's see if that works now. Come on, give me something. Yay! It looks more. It's not right, but it looks a lot better. It looks a lot better. Okay. I guess I can Control Z that and see if I can see something on there. Oh, it doesn't even work if you do that. We Control C that so it doesn't. Okay, so what do we have there? We have at least the head looks the way it's supposed to. We are not handling opacity properly, so there's gonna be a lot of things on top of each other. That's fine. And then there are some transform issues. Probably the flips, I'm guessing, are not getting mapped. I'm not sure actually. Either that or I have like rotation in the wrong direction, which is entirely possible. I've been looking for this exact library. Thank you so much for the super chat. Thank you. So one easy possibility that seems quite likely is that the angles are backwards. If you think about it, actually, this center part here is correct because I expect the bottle to be sitting down. I expect it to be upside down. So the chair is correct, and then this stuff here is wrong. So I probably have like XY swapped somewhere or a rotation swapped somewhere or something like that. So if I first of all I want to have some kind of global Y swap, so it looks fine when you have it finished. Let's just do. Let's just do a hacky final transform here. This will eventually be part of a shader and stuff, but for now this is good. And then I can at least test the opacity in here. Visual opacity. So that should get rid of some junk that is not supposed to be visible. Now, I don't even have the blend forms mapped yet, so... Okay, that's actually too little. That's unexpected. Did I get an opacity wrong somewhere? It's totally possible that we're just missing the blend forms. And that's really the only problem. Okay, let's not do the opacity check then. Actually, let's just check for opacity 0. Should be the same, because I guess everything is visible, I think. So if visible is off, that's a different problem. Yeah, okay, so it's an opacity problem. Let's see if it's just a rotation problem somewhere. I might just have the angle backwards. That's not better. So it could be the blend shapes. Oh, what just happened there? That's not supposed to be like that. Wait, hold on, what? Is visible also 0? Oh, that's not right. That means we have some visibility flags off? No. What? Hold on. Is this what broke it? Oh, right, because we're flipping across that axis, which is wrong. Okay, yeah, so hold on. Let's shrink everything and plus equals 0.5 just to see what else is in there. Okay, so nothing apparently. Oh, this is because culling is enabled. Right, this is because culling is enabled, that's why. Yeah, it's just because culling is enabled. I need to disable culling for now. But yeah, that's quite annoying. Let's turn off culling for now. Wait, but I did turn it off. I did turn it off, so why is it, why is it culling? Because I didn't set that. So culling is, okay, so now the chair is where it's supposed to be. And a bunch of things are wrong. So let's see what happens if I, say, invert the rotations. That did nothing, which is interesting, because I expected it to do something. That one shouldn't do much. No. So let's see. I don't think we have any of the flips here. I don't think we flip anywhere. We pretty much check that. I don't think that's a thing that's ever used. So then, what else could be wrong? It could just be the blend shapes. So I guess we could try doing that. But then we have to start merging. Well, we can look at the blends here. So these rod blend forms are probably the interesting ones. Okay, so this one is a zoom in and starts at scale 0, ends at scale 0.007. And that goes on deformer, rotation deformer 0. Oh, that's kind of interesting because we have we have a rotation bendform array applying to rotation deformer 0. And it seems to go from scale 0 to scale 0.007. That doesn't sound right. So how would you blend a rod form in? Okay, so not multiplicative because this is a move. So are they additively adding the scales? If so, that would make sense. But the null is all 0 on these, so this is not a case of it's not a problem with the rod deformers. So we don't know what the problem is. So our scales are correct, as all the parts have the right size, but they seem to have the wrong position. I wonder if this has something to do with the order of scale and rotation are applied in. Actually, yeah, what's the, how does this, affine to... Yeah, transition is applied after rotation, so that makes sense. Well, how about I just see if I can make sense of how these ended up in the wrong place. It could be the warp deformer extrapolation, but that just feels really weird that it would be so far off. Okay, I'm gonna turn off this angle. Thing, because I'm a little concerned. If we only do no, we need at least the translate. Oh, hold on. This doesn't make any sense. I'm dumb. This has to be the translation of the I'm dumb. This is the self-translation. Does it? It has to be, right? Yeah. if we are a child of a warp deformer, we take the translation and then that minus 0.1. Oh, hold on. Hold on. I just realized something. So if we have a warp deformer here, if we rotate, no, it has to be there. Is it possible that it is matching in the angle of the deformer? If you do angle 0, what happens? It's the same. Okay, so it is y minus 1. But we have to add the yeah, okay. That would probably do the what's going on here? So we need the translation of the affine matrix. And that's what we translate. And so then, we apply the warp deformer position for the translation here. Yeah, we basically have to redo the affine. It's just from scale angle translation. The scale is fixed. The angle is that. And the translation is P0, and we don't multiply by ST affine. Oh, okay, no, we only have the translation. Yeah, so the translation does to get converted. Okay, what we do is we just apply a scale and angle, and then we can do the translation. The translation is exactly the point. Or even just mat 2. Ah, okay, yeah, this makes sense. So we do don't define matrix 2 equals yeah. So we essentially we are applying the rotation and scale from the warp deformer, and then the translation becomes the vertex output because that is already translated. It's where it's supposed to be. Yay! So now we just have to figure out the opacity stuff. Let me try to check the opacity, see if I can get away with just checking the opacity here. So now only things that have non-zero opacity. There we go! And so the rest of that, I know that looks weird. That looks weird because we don't have clipping implemented yet. So the weird lips and stuff is the inside of the mouth that is not clipped properly. And same with the eyes that are also, there's an eye open that's probably not set to open. But there you go, that's the base model without any interpolations, without any parameters. And also without the right scale rendered. Which means we have the math for all the deformatory and stuff done correctly. So now, yeah, all that's left is basically fixing the rendering so it does clipping and oh my gosh, this terminal really doesn't like large things. So it does clipping and it does yeah, basically just clipping and opacity. And there you go. Then we have to actually implement the parameters, which is basically just interpolating between these forms in the input. There! Finally, we have a model, something that looks like a model. Alright, thank you everyone for coming. I should get some sleep because I have some plans tomorrow and I don't want to be too late for that. Oh, we did turn off culling. Let's turn on culling just to make sure that that is correct. I can fix that real quick. So if I turn on culling to see if that's... if I have it backwards or forwards. Oh, that did not work. Unwrap on a non-value. Wait, window event? What? That's just something weird. Ranger 417. Because because that. Okay, there we go. So that is... Oh, interesting. Some things are backwards then. But I'm forcing it on, so there's probably... if we use the actual modern... that culling... If we actually use the right setting... It might be that I have some things backwards, though. Ah, there it goes. So now it actually does the right thing. Alright! See you all next time! Thank you for coming! So next time, I'm pretty sure we can get the parameters interpolating, and if we're lucky, plug it into something else. There you go! Thank y'all! See you next time! Bye-bye! Bye-bye! See you next time!